So first thing I would like to share is pretty simple, one screenshot. So I have been doing databases for a really long time. I started with DBase 3 plus, and first time I might have seen that DBase was in 94. And I worked on DBase for like a year or so, then moved to Fox Pro. I worked extensively on Fox Pro for like maybe 2 years. Then in 1996 was the first time I saw Oracle at that time. And I can say I instantly fell in love with Oracle. So I started with Oracle 7.1, and that was running on a novel netware. It was a network based, but I never worked on the OPS or anything. It was just a single instance. And then I continued to stay with Oracle for a really long time. And in between, I picked up and did some DB2 in 2004 time. And then I also worked on MySQL 2007 to about 2012. When Oracle acquired MySQL, that's where the end of MySQL for me. I did not want to continue with it. I still work on Oracle, Oracle, Exadata, GG, DataGuard, a lot of products with Oracle. And in 2015 or so, we had a requirement to look at NoSQL database. And I did a lot of research, checking on different databases. And as I said, in 96, I fell in love with Oracle. In 2015, I fell in love with Cassandra. So when I started with Cassandra, obviously you are also starting. You will learn on the third day, you'll learn that only Cassandra cannot do. So you have to learn Apache Spark. So I fell in love with Cassandra. I know Apache Spark. I know like a lot of flavors of the sideways, like as soon as you start with Spark, you have to learn Scala. So I know Scala. I have never written a Java code on my own, but I understand Java. And basically I saw the Java beta 1 in 97 time when Java was getting started. So all these years I've been doing a lot of database work. And then staying current with a couple of technologies, like one is Oracle, and I've been doing Cassandra for 5 years now. So I gave you my what you say, like the intro. What we'll do, the thing is basically when you're starting with Cassandra, first thing I'll tell you, have relational database experience. Even if you work with MySQL or Oracle, it's just it's purely RDBMS side of it. So first thing I would say, open up your mind and forget about everything you know about RDBMS or databases coming into these sessions, because Cassandra is not RDBMS. And if we don't make up that mind saying, I have to forget everything I know, somebody says a table, forget that you know what is table. So when you come to Cassandra, you start fresh and you just imagine that you don't know anything about database. That will be the best way to learn Cassandra because it's completely different and very new. Everything you learned about Oracle, they told you, you're not supposed to duplicate data. You're supposed to normalize as much as possible. All those concepts are wrong in Cassandra. I mean, let's say somebody tells you, oh, I'm not getting performance, go create an index. That is completely wrong on Cassandra. Do not create indexes because you need performance. So have an open mind, and you definitely need to learn more than Cassandra. Apache Spark is the next thing to learn while learning this. Learning Java and Python is good. You don't have to write code on your own. You are going to stay with administration, but you definitely need to know what your developers are doing. Otherwise, they can create a lot of problems for you on your database. Hi friends, today we will download CentOS Linux and install it on our server. So let's first go to centos.org. On this website you will see there are two options here called CentOS Linux and CentOS Stream. We will go into CentOS Linux option and we will pick CentOS 7, and based on your system architecture you can download the uh, ISO file which you need, and we can go here to get our ISO file. I have already downloaded the disk image. We will use that image to install operating system on our server. I have started my system with the CentOS 7 disk, and you can see here we have an option to install the CentOS 7. So let's proceed to the next step. Now I'm going to choose English, so I'm not changing anything here for the language, and we'll just continue. Let me scroll down on the screen a little bit, and we will first start with installation destination. This is where we have to choose the hard drives being used for this installation. So I have two hard drives attached on this server. We have a 80 gig hard drive and a 100 gig hard drive. So operating system will install it on the 80 gig hard drive. So we'll select that, and also there are other options we can choose here. We can go with I will configure partitioning option, and we'll click on done. We'll select this option here called click here to create them automatically. Now we will adjust all these parameters here. So let's start with the home folder, and what I want to do is I want to allocate only 10 gigs for the home folder. Now let's change the swap to 16 gigs. Now we'll change the root to 53 gigs. So just review all of these settings, and we'll click on done and accept the changes it is going to propose for formatting our disk, and it is going to create all the partitions required for the operating system. We'll accept the changes. Next, we will adjust the security policy. So let's go to the security policy section and just switch off the security policy for now. We will click on done. Next, we will go to network and host name option. Here you can see we have two network adapters on our server, and we will switch on both of them. So we'll click here and switch it on, and if you wait for a second, it is going to connect and also acquire the IP addresses accordingly. I'll also go to the second one and switch on this network adapter and make sure it gets the IP address assigned. After we enable both of these network adapters, we'll set up our host name. Now this server, I'm going to call it as eternal one, and we will use a domain name oracle by example.com. and we'll apply these changes. Now we completed enabling the network options, and we also set a host name for our server. So let's click on done. Next we'll select what software to be installed on this server. So we'll go to software selection and we'll click on this option. Now what I'm going to do is to install very minimal stuff on my server. So I click on the minimal install option, and from the right side I will choose two options here: include the compatibility libraries, and we will include system administration tools. So we will try to install minimal required packages for our operating system. So what we did here was to choose the minimal install option, and we selected to install compatibility libraries and system administration tools. We'll click on done. And now if you notice, we can start our installation by clicking on this begin install option. During its installing, we can set up our password for the root user. So we can click here and set up a password. I'm going to pick a simple password which is not suitable for production servers. So here it is complaining that the password is weak. So it is saying password is not strong enough. But for this particular installation, just for a demo purpose, I'm going to just select a very simple password. And when I click on done, it doesn't take me to the next screen because it is still complaining about the password being weak. If I click done one more time, it will take me back to the previous screen where the installation progress, you can see here, it is installing all the required packages. We don't need to do anything else. We just have to wait for the installation to finish. Now, as you can see here, CentOS installation has been completed. So we can click on reboot to restart the server. As you can see here, CentOS has been installed. Now we can log in into our server. Server name is eternal1, and what I can do here is I'll log in as root user. Okay, we logged into the server now. Let's first check the IP address assigned to this server. We'll use IP command. Make a note of the IP address assigned to this box. Okay, for connecting to our server, I'm going to use a software called MobaXterm. I love this tool. This is a very good SSH client, and I have been using this for more than 5 years. Okay, so let's go ahead and connect to our server using MobaXterm SSH client. Let me first create a session to connect to our server. Our IP address for this server is 192.168.1.35. We'll use root user to log in. I will say OK. It will prompt for the password. So I'll type my password. And there you go. We connected to our server. Okay, remember we installed a very minimal required packages on our server. So some of the very basic packages might be missing. Now one of them I know is missing is the ifconfig command. So you can see here it says command not found. What we can do is to install the required packages. Sometimes these packages are also available on our installation media, or we can use yum, and this will require internet connection. So first let's check our internet connection by using a ping command. I'm going to ping oracle.com and see if I get response. So as you can see here, I'm able to ping oracle.com, and that means I have internet connectivity from my server. Okay, let's first install a package called nettools, which contains all the network related tools. One of them will be ifconfig. So what we can do here to install this package is we'll use yum. So we'll say this is the command to install nettools package using yum. Server will connect to the yum repository and try to download all the required package related files. It is asking me, is this okay to download and proceed to install? I will say yes. Now as you can see here, nettools package has been installed. Now let's verify our ifconfig command is working or not. Okay, now ifconfig command is working. So we can see here we have two network adapters on our server. So we can see here we have two network adapters on our server. In CentOS 7, network adapters are named and controlled by the network manager daemon. In most production environments, these network adapter names are not suitable for day-to-day operations. So we will now rename these network adapters to more standard names, and will configure static IP address for our server. This method looks complicated, but I'll try my best to explain it and make it straight and simple. Okay, to rename our network adapters, what we need to do is, first step, we need to edit a file called etc default grub. We need to edit this file. What we need to do is to locate a parameter called grub cmd line Linux. What I'll do is I'll make a copy of this line, and I will comment out the original line. We will add additional parameter to the end of the line here, and the parameter we are going to include is so we added a parameter called net.ifnames equal to 0. We'll save this file. So you can see here what we did is we edited this file called etc default grub, and we modified one single entry which is called grub cmd line Linux, and we added net.ifnames equal to 0 option. As you know, grub is the bootloader. We are going to apply this new configuration to grub, and we will do that using okay. With that, we completed reconfiguring our grub bootloader. We'll go to the next step. So using ifconfig command, I can look at the network adapter settings. I need to make a note of two things here. One is the network adapter name, and the second one is the MAC address. So make a note of these two things, and we'll proceed to the next step when we will use these MAC addresses and rename our network adapters to more standard names. To rename our network adapters and make sure they're assigned to the proper MAC addresses, we have to edit a file. We will add the following two entries. Let us save this file, and after saving, I'll explain what we did here. Okay, so as you can see here, this MAC address belongs to ENP0S3 network adapter. Now in this configuration we are saying this MAC address is now attached to a network adapter called ETH0, and as you can see here, this MAC address belongs to ENP0S8, but using this configuration we are now attaching it to a network adapter called ETH1. Next step is to make configuration changes in such a way that we assign the IP addresses and we use the standard network adapter names. We'll go into a folder called etc sysconfig network scripts. In this folder, all the network related scripts are stored, or the config files are stored. As you can see here, this file is the config file for the first network adapter. And as you can see, this is the config file for the second network adapter. This is the config file for the loopback adapter. These network adapter names might look different on each system, and also they might look different if you are connected using wire versus Wi-Fi. We'll make a copy of these files and use them for ETH0 and ETH1 adapters. Now let us edit the config file for ETH0. Okay, the first setting we will change is called boot protocol. We want to assign a static IP to this particular network adapter. Then the second setting we will change is the network adapter name. We don't need the entry called UUID, so we will delete this entry. We will change the device name also to ETH0. At the end of the file, we will add two entries to define our IP address. So what I'm doing here is we are setting up the network adapter name as ETH0. We are making it select a static IP during the restart. And the static IP address we assigned is 192.168.1.151. We'll save this file. Next, we will edit the config file for ETH1. We will configure this network adapter ETH1 with dynamic IP assigned via DHCP service. So first setting we will change is the name of the network adapter. We'll call it ETH1. We don't need this entry called UUID, so we'll delete this line. We'll change the device name also to ETH1. On boot, we want this particular network adapter to be available. So we want to make it on boot equal to yes. So as you can see, boot protocol is set to DHCP, meaning when the system restarts with the network adapter being brought online, a dynamic IP will be allocated for this network adapter. We'll save the file. We'll now restart the server and wait for the server to come back up. Looks like the server is back up, but remember we changed the IP address and assigned it a static IP, so we need to connect to the new IP address. So let's change our SSH connection settings. The IP address we assigned to the box was 151. Now let's start SSH connection to the server. Now let us run the ifconfig command again and verify our network settings are all looking okay. As you can see here, our network adapter names are changed to ETH0 and ETH1. ETH0 is assigned a static IP address. ETH1 is configured to get dynamic IP from DHCP service. Now our network adapter settings are looking good. Let's go ahead with the server review. Let's go ahead with the server review. We have installed CentOS Linux release 7.8 on this server. Hostname assigned to this server is eternal1 with the domain name is oraclebyexample.com. We have 16 gigs of memory allocated for this server. We have installed a very minimal required packages for the operating system. So you can see here memory used is 240 megabytes, whereas all the remaining memory, like nearly 15 gigabytes, is still available for whatever we want to install and run on this server. As you can see here, I have about 53 gigs allocated for the root file system. So next thing we will do is we will disable the security enhanced Linux and firewalls. First we'll check the security enhanced Linux status. As you can see here, security enhanced Linux is enforced. We will change the config file and we will disable the security enhanced Linux option. As you can see here, security enhanced Linux option is set to enforcing. We will make a copy of this line, comment out the original enforcing setting, and we'll change it to disabled. We'll save this file. We'll check the SE status one more time. And as you can see here, now the SE Linux setting from the config file, it shows it as disabled. It will require a system restart to disable the security enhanced Linux option. Next we'll check the firewall daemon status. As you can see here, this firewall daemon status is enabled and it is actively running. Let's stop the firewall daemon. Now we will disable the firewall daemon so it doesn't restart with the system restart. Let us check the firewall daemon status one more time. As you can see here, firewall service daemon has been disabled. Let us now restart the server. Looks like our server is back up and running. So let's reconnect to the server. I have logged into our eternal1 server as root user. As you can see, our server has been up only for a minute. Now let us verify our security enhanced Linux setting. As you can see here, security enhanced Linux has been disabled on this server. As you can see, the firewall daemon service is also disabled and it is not running right now. I always like to customize and add some custom aliases to bash rc because I use these commands a lot. I have just added this aliases to global bash rc file, so all users will be able to use these aliases in their sessions. In this session, we have successfully downloaded the CentOS Linux. We have installed CentOS Linux on our server with very minimal required packages. We have reconfigured the network adapters, renamed them to more standard versions, assigned them a static IP. We have disabled the security enhanced Linux and firewall daemons. This concludes the installation of operating system. We have logged into our Eternal One server as root user. I have attached a 100 gig disk on this server, which can be used for Cassandra. Let us now prepare this disk and get it mounted to the server. As you can see here, fdisk command has created a partition on this disk. Now, let us create a file system on this partition. Starting with Linux 7, XFS file system has become a standard. Let's create a XFS file system on this SDB1 partition. Now we can verify all the partitions on this system. As you can see here, this is our root file system, and this is the new file system we created on our 100 gig disk. Let us now mount this new file system. We'll create a folder for the new mount point. We'll be mounting our 100 gig disk on the mount point /apps/opt. To make that happen, we'll make a fstab entry. We'll make an entry in this file which will be used every time a system restarts, and it will auto mount all the mount points we need to mount on the server. We'll save this file. As you can see here, we made an entry in the etcfs tab file for our mount point. Every time a server restart happens, it will automatically mount our 100 gig disk onto this mount point. As you can see here, our 100 gig disk is not mounted yet. We can mount it without restarting the server using mount command. Mount -a will read through the fstab file and it will mount all the mount points again. As you can see here, our 100 gig disk has been now mounted as apps OPT on this server. We will use this mount point for Cassandra. Apache Cassandra will require Java to run. So we will install OpenJDK on this server. We have two options. We can install OpenJDK using yum, or the OpenJDK RPM packages are available on the operating system disk. On this server, we will use yum option to install OpenJDK. Now, as you can see here, we have successfully installed OpenJDK on this server. Since we installed it as a root user, all users on this server will be able to use Java without setting any Java home or anything. By default, they will all have access to this OpenJDK version 1.8. Apache Cassandra also requires Python. Python generally is pre-installed with the operating system, so we can verify if Python is already existing on this server. As you can see here, Python 2.7.5 is pre-installed on this server. If at all this is missing, you can also install it from your operating system disk. Now, let us create an operating system user group for Cassandra user. Now, let us create the Cassandra operating system user. I'm using user add command to create the Cassandra user. I'm assigning Cass GRP as the Cassandra OS user group. Using home option, I'm specifying to assign a home for Cassandra user, and this home will be created because we have specified create home option. I'm assigning bash as the shell for the Cassandra user. Using password option, I'm setting up the default password for Cassandra user. We can change the password later on, and using simple passwords is not suggested for production servers. We can verify if Cassandra user is created properly. As you can see here, Cassandra user exists on this server. It is assigned to CAS GRP OS group. Hi friends, in this session we will install open source version of Apache Cassandra on a 3-node cluster. I have logged into Eternal1 server as Cassandra user. I have 3 servers called Eternal1, Eternal2 and Eternal3. I have added these entries into etc host file. We will be downloading and installing open source version of Apache Cassandra on these 3 nodes. Let us try to ping other 2 nodes from this server. I have already verified that all 3 nodes are able to communicate with each other. Apache Cassandra requires Java to run. As you can see here, I have installed OpenJDK version 1.8 on this server. Apache Cassandra also requires Python to run. As you can see here, Python 2.7.5 is already available on this server. Note that all nodes in the cluster should have exactly same prerequisite versions of Java and Python, and it also requires the storage and the file systems to be similar. Now let's go ahead and see how to download Apache Cassandra software. As you can see here, I went to the website called cassandra.apache.org. This is the home page for Apache Cassandra software. You can read a little bit about Cassandra on this web page. I want you to notice that Apple has 75,000 nodes in Cassandra clusters, and it holds about 10 petabytes of data. Netflix has 2,500 nodes in Cassandra clusters. Let's go ahead and download Cassandra software now. As you can see here, download Cassandra option is available right here. As of today, Cassandra 3.11.6 is the stable release available. This was released on 14th of February 2020. Let's go ahead and click on the version here, which will take us to the download page. We can click on this link to download Apache Cassandra software. As you can see here, I have already downloaded Apache Cassandra software on this server. I have downloaded this software to all of my nodes. Notice that Apache Cassandra open source software is only a 36 megabyte zip file. This same 36 megabyte zip file contains a software which can run on thousands of nodes in a single cluster. Now let us extract Apache Cassandra software. We have to download and extract this software on all of the other nodes we have. Now let me extract the software on my second node. Now I will extract the software on my third node. Notice that I'm back on my node 1. This is the folder where Apache Cassandra software got extracted. Let us create a soft link to this folder. We have to create the same soft link on all nodes. Now I will create this soft link on my second node. Now I will create the soft link on my third node. We have to create various required folders for Cassandra software to operate. We have to create these folders on all of our nodes. On all of our nodes, we need to create these folders for Cassandra to save its files. This folder will be used to save cache files. Cassandra uses hints, and those hints related files will be stored in this folder. Commit log files will be stored in this folder. All the data files related to SS tables will be stored in this folder. CDC is change data capture. CDC related files will be stored in this folder. Cassandra allows custom triggers. Triggers related files will be stored in this folder. System logs and other log files will be stored in this folder. Now let us create these folders on our servers. Notice that I'm back on my eternal 1 server. I'm going to make a copy of all the original configuration files and place them in the conf folder. I'm also changing permissions of all the files in the conf folder so that others don't have access to read, write, or execute. These are all the configuration files for Apache Cassandra software. Initially, we will be editing configuration files only on one node. Later on, we can copy these configuration files to the other nodes in the cluster. First, we will edit cassandra.yaml file. This YAML file is very well commented, and they have already explained what each parameter means. We are going to go through this file and edit few of these parameters for our installation. First parameter I'm going to change is the cluster name. I generally like to have cluster names without any spaces in them. I'm going to comment out the original entry. I'm going to copy that entry and edit the new entry. As you can see here, I would like to call my cluster as ID cluster. We will scroll down a little bit and find the next entry to modify. Next parameter I would like to change is the num tokens entry. It is suggested to reduce the number of tokens. For a small cluster, number of tokens should be 8 or 32. If it is a very small cluster, like we are going to build a 3-node cluster right now, I'm going to use 8 tokens per node. As you can see here, now each node in this cluster will have only 8 tokens assigned to each node. 256 is a very large number of tokens, and it is suggested to reduce the number of tokens to 8, or maybe if a large cluster is there, you can increase it to 32. Let's scroll down and find the next entry to edit. Next entry I would like to change is the hints folder. Cassandra stores hints, and I would like to store these hints in a specific folder. Remember, we created these folders, so I'm going to choose one of those folders to store my hints files. Next parameter I would like to change is called data file directories. This is the directory location where SS table related files will be stored. Note that data files can be split into multiple mount points. Each data file will contain unique data. You can have multiple mount points to store these files related to SS tables. Earlier, I have created this data folder, so I have specified data files related to SS tables to store in this folder. As you can see here, I have also specified which folder to use for commit logs. Recently, Cassandra has introduced change data capture option. As you can see here, by default, change data capture is disabled. As you can see here, I'm using this folder to save CDC related files. We are not going to change this entry, but I want you to notice what happens if at all a disk failure happens. Cassandra will just stop. There are other options like best effort, die, or stop paranoid. I will leave this to default option of stop. I want you to notice this option where if at all Cassandra is unable to write commit logs to the disk, then its default behavior is to stop. There are other options available like stop commit, ignore the errors, or die. I'm going to leave it at its default option. Next parameter I'm going to set up is for saved caches directory. So when Cassandra starts running, any cache files will be saved in this folder. Next parameter I need to change is the seeds entry. This is important to understand. Seeds are used by Cassandra when a new node is joining a cluster. The process of joining a new node into the cluster is called bootstrapping. So the new node which is joining the cluster will contact these two seed nodes to request for information related to the cluster. If you have a very large cluster of 20 nodes, you do not want to specify all the nodes in this seeds entry. You should elect only 3 or 4 nodes to act like a seed. So remember, not all of your nodes in the cluster should act like seeds. You should only elect few nodes to act like seeds. I want you to notice the storage port and the SSL storage port allocated here. You need to protect these two ports and if needed, add rules to your firewall. Cassandra will listen to incoming requests on this listen address. Imagine if your IP address changes for some reason, Cassandra will fail. So it is better to listen on a network adapter, not bind it to a specific IP address. So I have commented out listen address option. Instead, I'm going to use listen interface option. When I bring up this Cassandra cluster, this particular node will listen on the listen interface. So it doesn't matter what IP address it has, it will listen to the incoming request using the ETH0 network adapter. This is the option if you would like to use IPv6. Native transport is where the SQL connections come in. So native transport port is 9042, and when the Cassandra is starting on this node, it will by default bring up the native transport. RPC was used for the old thrift protocol. As you can see here, by default, RPC will not start. Even though RPC is disabled, I would like to set up RPC interface and not the RPC address. RPC will not start by default, but if at all you have to start RPC, you will change this parameter. In case if you enable RPC, RPC will use ETH0 network adapter. Notice these parameters which can be used for incremental backups and snapshots before compaction or auto snapshot options. Snitch is a very important concept in Cassandra. Snitch decides where to save your data in the cluster and how to provide replication. For this installation, I'm going to use gossiping property file snitch. For most production systems which are running on-premises data centers, gossiping property file snitch is the best snitch. I would suggest not to use simple snitch for any cluster. There are many other parameters related to monitoring and performance tuning. But we don't need to change any more parameters for this installation. I will save and close this file. Because we are using gossiping property file snitch, we have to change this configuration file. I will now edit this file. There are only two parameters we need to specify in this file. One is data center and the rack is the location of the server. In this case, my servers are located in East Data Center. You can name your data center in any way. It doesn't need to be the physical name of the data center. It can be a virtual data center name. A rack is the location of your server. Imagine you have a building 1 in your data center and my server is sitting in building 1. And let's say my server is on the floor 2. And let's say it is on the bay 3. Rack is very important information you're providing Cassandra so that none of the replicated data is saved on the same floor or the same bay. If you have a large cluster, it is always better to distribute your data in such a way that if at all an entire building loses its power, your replicated copy is not stored in that building, it will be stored somewhere else. Cassandra will make the decision based on this rack information you provide. For this particular installation, I'm just going to say my rack is nothing but rack 1. I'm going to save and close this file. Next, we are going to edit this file to add environment variables for our Cassandra installation. I'm going to insert 4 new entries right after this comment section. This environment file will be used every time Cassandra is starting on a node. This environment variable is for Cassandra home location. This environment variable is for Cassandra configuration files location. This environment variable is where the Cassandra log files will be stored. In case of JVM crashes, heap dumps will be stored in this folder. We'll save and close this file. As you know, Cassandra runs in JVM, and all the JVM related settings we can specify in this file. We are going to edit this file called jvm.options. There are 3 settings in this file I would like to show. First 2 are related to the JVM memory options. By default, JVM has a default formula to calculate how much memory to allocate. In case if you want to allocate specific amount of memory, like say 8 gigabytes per node, then you can tweak these 2 parameters. Remember that when using the default garbage collector, it is not suggested to go beyond 8 gigs of memory for the JVM. If you want to set up more than 8 gigs for JVM, then you need to think of using G1 GC. As you can see here, I have changed the memory options to 8 gigs. So minimum memory allocated for JVM will be 8 gigs and maximum is also set to 8 gigs. As you can see here, this parameter is used to specify where the garbage collector log will be stored. I have changed two parameters related to the memory settings. Parameter names are XMS and XMX. And the last parameter I changed is the garbage collector log location. Parameter name is xlog_gc. I will save and close this file. Next, we are going to edit bash profile file and set up few environment variables. As you can see here, I have added an entry for the environment variable called Cassandra home. Here is an entry for Cassandra configuration files location. And I have included Cassandra home/bin folder in my path. I will save and close this file. We can exit from this session and re-log in to get all the proper parameters set up via bash profile. I have closed the previous shell and started a new connection to Eternal 1 server as Cassandra user. As you can see here, my shell has Cassandra home and Cassandra configuration files locations set as environment variables. Cassandra home/bin folder has been added to my path. With this, we have completed editing all the configuration files required for Cassandra software to run. Let us now verify if Cassandra is already running on this node by using ps command. As you can see here, none of these processes belong to Cassandra. Node tool command is provided with Cassandra software, and we can use node tool to verify if Cassandra is running. As you can see here, Cassandra is not running. We can use Cassandra command to start Cassandra server on this node. Let us use nodetool status command to check the Cassandra server status. As you can see here, Cassandra is up and running on this node. As you can see here, this is the system log. Whenever Cassandra is running, or it is starting or shutting down, it will write all the messages to this system log file. Let us review the system log file to understand all the startup related messages. As you can see here, this is the configuration file used by Cassandra to start the server. You can see here Cassandra has detected OpenJDK version 1.8. Here is the entry for where JVM heap size is set to 8 gigabytes. As you can see here, system related tables are being initialized. As you know, Cassandra was starting first time on this node and there are no previous commit log files, so it is saying no commit log files found. Cassandra has detected that this is a new node and it created a host ID for this node. Creation of host ID will happen only once. As you can see here, Cassandra is starting gossip. Here are the 8 tokens allocated for this node. These are randomly generated 8 tokens assigned to this node, and this node in the cluster will handle all these tokens. When starting Cassandra, we always look for this message called no gossip backlog proceeding. That means Cassandra server startup has completed. As you can see here, we have one node in our cluster and it is up and running normally. Now that we have one node cluster running, let's add the second node into this cluster. As you can see here, I have logged into Eternal2 server as Cassandra user. Using this command, I can copy all the configuration files we modified on the server 1 to this node. Yes, I want to continue. I have to provide Eternal1's Cassandra user password. As you can see here, we have copied all the configuration files which we modified on the server 1 to this node. Using this command, I'm copying the bash profile file from the node 1 to eternal 2 server. On this server, we don't have to log off and log in again, but we just source the bash profile file to set up the environment variables. We know that Cassandra is not running on this server, so let's just start it. While Cassandra is starting on the second node, let's go to the node 1 and verify the cluster status. As you can see here, second node is joining now. As you can see here, node 2 has generated 8 new tokens, and node 2 will be handling these tokens from now onwards. As you can see here, bootstrap of Cassandra node is starting. As you can see here, this node has completed joining into the Cassandra ring. As you can see here, now we have 2 nodes in our Cassandra cluster. Notice that I have logged into Eternal 3 server as Cassandra user. Using this command, I will copy all the configuration files from Eternal 1 server to this node. As you can see here, I have also copied the bash profile from the first node to this server. Using source command, I'm reloading the bash profile to set up all the environment variables. As you can see here, our Cassandra is not running on this server. I will go ahead and start Cassandra on this server. So it will perform the bootstrap, it will generate unique tokens for this node and join the Cassandra cluster. As you can see here, our cluster now has 3 nodes up and running normally. Notice that I logged into Eternal2 server as Cassandra user. We have all three nodes up and running normally in this cluster. I'm going to shut down Cassandra on this node. Using the node tool drain command and node tool stop daemon command, we can shut down the Cassandra properly. Let's go to another node in this cluster and verify the cluster status. As you can see here, our second node in the cluster is down normally. In this session, we have downloaded Apache Cassandra version 3.11.6 and installed it on a 3-node cluster. Hi, let's talk about Apache Cassandra's authenticator and authorizer. As you can see here, I am connected to Eternal1 server as Cassandra user. In the previous sessions, we have built this Apache Cassandra 3-node cluster. If you notice, all my Cassandra nodes are up and running. By default, out of the box, Apache Cassandra does not authenticate or authorize when the users log in. Out of the box, Apache Cassandra provides two authentication methods: allow all authenticator and password authenticator. As you can see here, authenticator is configured for allow all authenticator, meaning it will not do any authentication. Essentially, authentication is disabled. Any user can log into Cassandra. Out of the box, Cassandra provides two methods for authorizer: allow all authorizer and Cassandra authorizer. By default, it is configured to use allow all authorizer, which means authorization is disabled. Any user can log in and perform any action on Cassandra database. In this session, we will secure our Apache Cassandra database using authenticator and authorizer. We can use CQL-SH to connect to our Cassandra database. As you can see here, CQL-SH connection has failed because it is trying to connect to localhost or connecting to the loopback adapter. Since we are running a multi-node cluster, we are supposed to provide which host to connect to. I'm going to use this command CQL-SH with passing the host name as a parameter to connect to our Cassandra cluster. As you can see here, using CQL-SH, we are connected to our Apache Cassandra cluster. Cluster name is ID cluster. We are using Cassandra 3.11.6. Before we enable Cassandra authentication and authorization, we have to change replication factor for few key spaces. So let's take a look at the current settings for these key spaces. As you can see here, system auth key space is using a simple replication strategy, and replication factor is set to 1 by default. As you can see here, system distributed and system traces key spaces are also configured with simple strategy for replication, and replication factor has been increased here. In this case, these are set to more than 1. As I said, to enable authentication and authorization in Cassandra, we are going to change the replication strategy and the replication factor settings for these 3 key spaces. I have connected to our Cassandra cluster using SQL.sh. As you know, I have 3 nodes in my Cassandra cluster, and they all belong to one data center called East Data Center. Using this command, I have changed system auth key space settings to use network topology strategy for replication, and replication factor is set to 3 for East Data Center. My suggestion for replication factor setting for system auth key space is just to replicate on all servers. Using this command, I have changed the replication strategy and replication factor for system distributed key space. We are using network topology strategy for replication, and I'm going to keep only 2 copies on my East Data Center. Using this command, I have changed the replication strategy and the replication factor settings for system traces key space. I'm using network topology strategy for replication, and I'm going to keep only 2 copies on East Data Center for system traces key space. With this, we have completed changes to our key spaces. Let's go ahead and modify the Cassandra YAML settings. Before changing any settings, I would like to take a backup of my config file. Let us go ahead and edit our Cassandra YAML file. I will edit the Cassandra YAML file on my first node and copy it to the other nodes in the cluster. As you can see here, by default, authenticator is set to use allow all authenticator. Means authentication is disabled. All users will be able to connect to Cassandra. As you can see here, I have commented out the original setting, and I have changed the authenticator to password authenticator. As you can see here, right now authorizer is disabled by setting it to allow all authorizer. We will change this. I have changed the authorizer to Cassandra authorizer. Here you can read a little bit about the role manager. I will now save the file and close it. I'm using scp command to copy my Cassandra YAML file to the other two nodes in this cluster. Next step is to restart our Cassandra cluster. To stop Cassandra on this node, I'm going to run node tool drain command. When you use the node tool drain command, current node will inform rest of the nodes in Cassandra cluster that it is going down and it will not accept any new connections. It will not accept any new connections from clients or even from the other nodes in the cluster. It will flush all memory objects to disk, such as mem tables will be written onto the sorted string tables, SS tables on disk. Now at this point, when you finish drain, essentially this node is in an unusable state. Basically Cassandra process is up and running, but it doesn't accept any new connections. Even it does not listen to any connections from the other nodes in the cluster. Gossip itself is shut down. The only thing we can do is to shut down the Cassandra daemon process and restart Cassandra. Using node tool stop daemon command, we can stop the Cassandra daemon. As you can see here, Cassandra has been shut down on this node. We will now start Cassandra on this node. We have restarted Cassandra on this node. Let's proceed to the next step. If you notice, my SQL SH connection to the database has failed. It has failed authenticating to Cassandra database because we enabled the authentication. So now onwards, nobody can connect to Cassandra cluster without a password. We can try to use the default Cassandra user to connect to our database. It is prompting for the password. I have cancelled that login. As you can see here, using this option, I'm providing the username and password at the command prompt. You can see we have provided the username as Cassandra and the default password for Cassandra is Cassandra. And now we are able to log into our Cassandra database. Users with Cassandra role can log in, and also Cassandra role is given a super user privilege. We will create a new super user role on this cluster. I have used create role command to create a new role. I have assigned Thor a super user privilege. Users with Thor role can log in. I have set password to be complicated. I will also create a secondary role and grant minimum privileges. As you can see here, I have created a secondary role called Loki. Loki is not a super user. Loki can log in, and password is set to simple. Only privilege I granted to Loki user is select on all key spaces. Let's exit from this SQL shell session and reconnect as Thor user. As you can see here, we are connected to our Cassandra cluster using a newly created Thor super user. As you can see here, this is the default Cassandra role. We have created Thor as super user, and Loki has minimum privileges. Loki is not set to be super user. We can have roles which will not be able to log in and still have some permissions on the cluster. We should disable the default Cassandra role so no users will be able to log in using that role. Using alter role command, I have changed the settings for Cassandra role. I have removed the super user privilege, and also Cassandra role cannot log in. Password has been set to very complicated password, so nobody can by mistake provide a password and connect. As you can see here, the default Cassandra role has been disabled. It cannot log in and it does not have super user privileges anymore. I have created a Thor as a new super user on this cluster, and I recommend to actually drop the original default Cassandra role. Either you can leave the Cassandra role in a disabled mode or you can drop it. My personal recommendation is to drop the Cassandra role. So I created a new super user role called Thor. I have also created a secondary role called Loki and granted only select privilege. I have also dropped the default Cassandra role which was provided out of the box with Apache Cassandra. We have to restart Cassandra on all the nodes in this cluster. Notice that I have logged into Eternal2 server as Cassandra user. Using this command, I will restart Cassandra on this node. As you can see here, I have logged into Eternal3 server as Cassandra user, and I will restart Cassandra on this node. I'm back on my Eternal1 server. As you can see here, we have completed restart of Cassandra on all nodes. Cassandra is up and running on all of our nodes now. Let's talk about a special file called SQL-SHRC. As you can see here, this SQL-SHRC file does not exist. Let me create the file and then explain how it works. Here I need to provide the host name to which it will connect. I will use a special mechanism available with VI. I will press escape : R bang hostname. And you can see our hostname got inserted into the file. I will save and close this file. Just like bash profile file for the bash shell, SQL SHRC file has the default settings for SQL SH. Essentially what we are telling is every time a user types SQL SH without providing any parameters, it will use the default username Loki and allow the login with this password. Connection will be made to this host name. It will use this port to connect. I strongly recommend you change the permissions for this SQL SHRC in such a way that only user can read write. Everybody else in the group and others cannot read, write or execute on this file, especially because it contains the default password you're using to log into your cluster. And remember, we created Loki with a very minimum privileges, so if anybody connects, they cannot drop anything from the database. Now that we have created a SQL SHRC file, let's test out our default connection by using SQL SH command. So here you can see I have logged in without providing any username password, and also I did not tell which host to connect to. But we are able to connect to Cassandra cluster. if you notice in the prompt, we have logged in as low-key user. We have connected to ID cluster running on node eternal 1. With this, we have completed enabling authentication and authorization setup for Apache Cassandra. Let's discuss a little bit more about the roles and permissions in Cassandra database. I will first connect to my cluster using SQL SH, and I'm connecting as the super user Thor. On this cluster, I have an application key space called sales. As you can see here, sales key space has 3 tables. Since we have enabled authentication and authorization in our cluster, we have to create few users which will be used by the application team to connect to this cluster. As you can see here, I have created a new role called sales read write user. It is not a super user and it can log in with this password. Using this grant command, I'm granting all permissions on sales key space to this newly created role sales read only user. Using list permissions command, I can see what permissions are granted to a role. As you can see here, I have created another role called sales read only user. This role is not a super user. Users with this role can log in and they have to provide this password. As you can see here, I have granted only select privilege on sales key space to this newly created role sales RO user. Users who log in with sales RO user role, they cannot change any data in the key space. This is the grant command syntax. We can grant all permissions or we can grant specific permissions on a resource to a role. This is the syntax for revoke command. Revoke specific permission on a resource from a role. These are all the possible permissions. These are all the possible resources we can grant privileges on. We can grant on all key spaces or a specific key space or a specific table in a key space, or a permission can be granted to all roles or a specific role. We can use the list command to check the permissions granted to a role. In this session, we have enabled authentication and authorization on our Apache Cassandra cluster. We have created new super users and we have dropped the existing default Cassandra role. We have also discussed about roles and permissions for the application users. Hi friends. In previous sessions, we have built a 3-node Apache Cassandra cluster in a single data center. As you can see here, all my Cassandra nodes are up and running normally. I got 3 new servers in West Data Center. These servers are named as Doom 1, Doom 2, and Doom 3. These servers are located in West Data Center. In this session, we will add these 3 new nodes to our existing Cassandra cluster and configure it as an Apache Cassandra cluster in multi-data center configuration. I have added all these entries to my etc host file on all servers. Note that for Apache Cassandra to work, we do not need to have all servers on the same network subnet. Nodes can be on different network subnets. As long as they can communicate using gossip on network, Cassandra will work. Notice that I have logged into Doom1 server as Cassandra user. I have already downloaded and extracted Apache Cassandra software on all new servers. I have also created a soft link for Cassandra home folder. On all new servers, I have already created all the required folders for Apache Cassandra. I'm using this amazing SSH client tool called MobaXterm. It has tons of wonderful features and I have been using it for a very long time. If you are not already using this tool, then I would seriously recommend you to try MobaXterm and you will fall in love with it. One of the excellent features of MobaXterm is multi-execution mode. We can connect to multiple servers and run the same command on all servers in one shot. As you can see here, I am connected to 3 new servers called Doom 1, Doom 2, and Doom 3. I have logged in as Cassandra user on these servers. Using this secure copy protocol command, I will copy all the Apache Cassandra configuration files from our eternal one server to these new servers. Using this secure copy protocol command, I will copy bash profile file from our eternal one server to these new servers. On these new servers, we will modify the Cassandra rack DC properties file to specify the location of each server. All these servers are located in West Data Center. So I have specified DC equal to West DC. Note that data center can be virtual. Imagine you need 6 nodes in reporting data center and they will be used only for running reports. Live application will be configured in such a way that it will not connect to reporting data center. Apache Cassandra 4.0 is going to introduce a new method called network authorizer. Using this network authorizer, we can restrict user access to certain data centers. Now we will specify the physical location of each server using this rack parameter setting. Note that using this option, we can avoid typing commands into disabled terminal. My Doom1 server is located in Building 1, second floor in Rack 3. My Doom2 server is located in Building 5, second floor in Rack 8. My Doom3 server is located in Building 3, 7th floor in Rack 4. I will now save this file and close it. I will close my current SSH connections and I will re-log into these servers. I am back on my Doom1 server as Cassandra user. Now we are ready to bootstrap one node at a time and add these new nodes to our existing Apache Cassandra cluster. Let us start Cassandra on Doom1 server. This will go through bootstrap process and if everything goes okay, this node will be joined into existing cluster as a new node. As you can see here, our Doom1 server is now a fourth node in our Apache Cassandra cluster. Cassandra on this node is up and running normally. I have logged into Doom2 server as Cassandra user. Now I will start Cassandra on this node so it can bootstrap and join the cluster. We got this no gossip backlog message, so we can proceed to the next step. I have logged into Doom3 server as Cassandra user. Now I will start Cassandra on this node. As you can see here, we have successfully added our three new nodes to our previously existing Apache Cassandra cluster. Cassandra on all six nodes is up and running normally. Notice that these three nodes are in East Data Center. These three nodes are in West Data Center. We have modified Cassandra rack.dc properties file to specify the location of each server. As you can see here, rack information is populated properly. I have logged into Doom2 server as Cassandra user. As you can see here, my SQL command has failed with an authentication error. After adding new nodes to the cluster or after removing nodes from the cluster, we have to change replication factor for system auth key space. I have logged into Eternal1 server as Cassandra user. Note that currently all our Cassandra key spaces are set to replicate data only within East Data Center. Using SQL I have connected to our Cassandra cluster with Thor superuser role. Now I will change the replication settings for our Cassandra key spaces. Using alter keyspace command, I have modified the replication factor for system auth keyspace. Now onwards, for system auth keyspace, Cassandra will maintain 3 copies of data on each data center. For system distributed and system traces keyspaces, Cassandra will maintain 2 copies of data on each data center. Note that replication factor setting can be different on each data center. They don't need to be same. For sales key space, I have configured it to maintain 2 copies of data on each data center. But on West Data Center, I have configured it to maintain 3 copies of data. In this session, we have added 3 new nodes to our existing Cassandra cluster and configured it as an Apache Cassandra cluster in multi-data center configuration. We have also changed replication factor settings for our key spaces to match with our multi-data center configuration. Hi friends, in this session, let us discuss about Apache Cassandra's node tool. Node tool is like a Swiss army knife for Cassandra administrators. First command we will check is node tool status command. This is a cluster-wide command, meaning we can get information about all nodes in the cluster. As you can see here, my Cassandra is configured to run in multiple data centers. I have three nodes in East Data Center and I have three more nodes in West Data Center. Cassandra on each node can be up or down. It is indicated with status flag. As you can see here, one Cassandra node in my cluster is down and remaining five are up. Cassandra on each node can be in one of the four states. It is indicated with the state flag. As you can see here, all my Cassandra nodes are in normal state. These are the IP addresses of Cassandra nodes. Load indicates how much data is being handled by each Cassandra node. In most ideal scenario, if all the data is properly balanced, then this load should approximately be same on all nodes. As you can see here, each Cassandra node in my cluster is handling 8 tokens. Owns indicates the percentage of data that is being handled by each Cassandra node. In most ideal scenario, if all the data is properly balanced, then this percentage value should be approximately same on all nodes. A unique host ID is assigned to each Cassandra node while the node is bootstrapping. If you remember, we have configured location of each node in Cassandra rackdc properties file as a setting called rack. Node tool status command is very useful to quickly figure out if any Cassandra nodes are down in the cluster. Node tool status command can be executed with a special option called resolve IP. As you can see here, instead of printing IP addresses of Cassandra nodes, resolve IP option will print host names of Cassandra nodes. Node tool describe cluster command can be used to retrieve Cassandra cluster information. Our cluster name is ID cluster. We are using gossiping property file snitch. Looks like this node in our cluster is down. Node tool ring command can be used to retrieve information about tokens. I have configured to have 8 tokens per node. So far, we have covered few node tool commands which work at cluster level. Now let us check a few node tool commands which work at node level. Node tool version command can be used to retrieve the Cassandra version. As you know, we are running Apache Cassandra version 3.11.6. Node tool status binary command can be used to check if our native transport is running or not running on this node. Clients cannot connect to Cassandra on this node if native transport is not running. Node tool status gossip command can be used to check if gossip is running or not running on this node. Node tool info command can be used to retrieve Cassandra node information. As you can see here, Cassandra on this node has been up for 4227 seconds. This is the JVM heap memory used versus allocated on this node. This is the data repair percentage on this node. Usually, we want this to be near 100%. Node tool netstats command can be used to retrieve network related information for Cassandra. Dropped messages means we have some network related issues. In this session, we have discussed a little bit about Apache Cassandra's node tool. Node tool has like 95 different options and we only looked at 8 of them. In this session, we will configure passwordless SSH login between our Linux servers. As you can see here, I have 6 servers and I have connected as Cassandra user to each of my servers. Right now, passwordless SSH is not configured between these servers. I can use SSH to log into a remote server and run few commands. Because this is first time we are trying to connect to a remote server, it is asking me if I would like to continue connecting or not. I will say yes. And notice that it is asking for the remote server's password. Idea is when we complete our passwordless SSH configuration, we should be able to run commands without providing this password. As you can see here, .ssh folder does not exist. That means we have never created SSH keys on these servers. First step in configuring any SSH connections is to create private key and public key for each server. We can use this command ssh keygen to generate RSA keys using SHA 256-bit algorithm. I'm going to choose all the default options. And now we have generated RSA keys using SHA 256-bit algorithm. This is the private key file. Only user should be able to read write on this file. Anybody else in the group or others should not be able to read, write, or execute on this file. This is the public key file. User should be able to read, write on this file. Anybody else in the group or others should have only read permission on this file. Now that we have generated RSA keys for our servers, next step is to exchange these keys between servers. Using SSH copy ID command, we can copy our public keys to the other servers. This is first time we are trying to connect to the remote server. So it is asking me whether I want to proceed. I will say yes. For the first time when we are copying these keys to the remote servers, it will ask us for the password. So I'm going to provide Cassandra user password on the remote server. We were able to add the key to the remote server. I have to repeat the SSH copy ID command for each server. Okay, with this I have completed adding all keys to all servers. We have 6 servers. As you can see here, it created 2 new files in .ssh folder. Authorized keys contains all the keys from all servers added to the current host. Authorized keys file is protected in such a way that only current user can read, write on this file. Anybody else in the group or others cannot read, write, or execute on this file. SSH copy ID command also creates a file called known hosts. Basically, this is the list of all the trusted hosts you have added to your server. As you can see here, we have 6 keys stored in authorized keys file, 1 key for each server. Now let's try to run some commands on a remote server using SSH. As you can see here, now it did not prompt for password because we have already configured passwordless SSH by exchanging the public keys between each servers. So essentially we have made the servers trust each other using the public keys. In this session, we have configured passwordless SSH login between our Linux servers. Network. Is network important for us? So our database is a distributed database. Without network, nothing can work. Okay, so I put like a basic slide. We don't need to really go through this whole thing, just to understand what is a network. So we have our home network, we have our office network. Now we use VPN to connect because we're all working from home. Then we have wireless networks, wired networks, mobile networks. Um, for every device, we have something called MAC address, and every device will have IP address. IP address is assigned in two methods. One is DHCP, which is a dynamic IP assigned to the devices, or there is a DNS server which will assign these IP addresses, and then you can say, I'll have fixed static IPs for the devices. Now, so that's where the network domain comes in. Like you are in a home network, you'll connect with your home domain, or you're on your office network, you'll have a network domain assigned to you from the office network, work network. So dynamic IPs, static IPs. Now there are something called private IPs, public IPs. So the cloud, when you put this cloud into the picture, you get few more extra things into the IPs or network area. So then we do understand that network is important because our database is a distributed database. We need network. Without network, we cannot do anything. And obviously, you cannot switch off your Wi-Fi. If you switch off your Wi-Fi, kids go crazy. So, they imagine that connectivity is like basic. So going into AWS, now we choose AWS to do our all our work, like trying out our Cassandra on EC2s and all that. So basically, in AWS, we need to understand some basic terminology here, like the AWS region, VPC, Internet Gateway, route tables, subnets, security groups, and EC2s. So it's not like you sign up for a AWS account and you can launch EC2. It's not true. You have to understand a little bit more. And what we'll do is we'll look at one more slide here, and I'm not going to really ask you to read through that slide. What we can do is we'll launch our EC2 and we'll do all these things in that whole thing. Let's talk about what software and how to get the documentation for what we are learning. Now we have two choices. Either you can build your virtual machines on your home laptop, desktop, using VirtualBox, or we can use EC2s in AWS. So these are the two options, and I definitely suggest you trying both options. For Cassandra, there are a few differences here and there, and you can see here I'm just going to show you my VirtualBox setup. I have a bunch of machines. I always try to experiment with different settings. And I've been trying EC2 a little bit. But for me, home VirtualBox is much more convenient because then I have more control on what is going where, IP addresses and stuff. But you're welcome to try either way. Cassandra itself does not change a lot, whether you use VirtualBox or the EC2s. Okay. Then let's see what else we need. We need CentOS if you're running it on VirtualBox. You are welcome to try other Linux distributions. I generally like CentOS because it is very close to the Red Hat Linux, and any organization you go into, officially they might be using Red Hat, and which is very close to what is CentOS looks like. On Amazon, we can use the Amazon Linux too, which is provided as AMI, and to launch our EC2, we can use that. So for now, what I'm going to do is I cleaned up my Amazon account, and I don't have VPC, I don't have any subnets, and nothing is available right now. So what I'm going to do is just start with something called region. Okay. So AWS, the infrastructure is everywhere in the world. And first you specify which region you want to be in. So for example, you can go into North Carolina or Oregon, which is closer to the west side. And then probably can launch some EC2s in Mumbai, which could be closer to them, or they can pick Singapore or Tokyo. So first we have to pick a region we want to work in. So as you see here, I have the Virginia US East 1 as the region set. Okay, so within that region, we have to create a VPC. VPC is virtual private cloud. Imagine that is your own data center in Amazon, but again, it is under North Virginia region. So we'll go to VPC, and by default, your account might already have a VPC. In my case, I had a VPC, I deleted it so that we can start fresh and go through all these different options. So what I'm going to do is I'll just say create VPC, and then you have to provide some name. So let me just say create VPC. So I generally like to put a underscore VPC or underscore subnet or whatever we are creating. That way it doesn't cause any confusion. Now, so what I'm going to do is I'll specify for my own VPC, I'll say 24.24.0.0/16. Now, if you remember this CIDR XYZ, so let's say, for example, if you put 24.24.0.0 and 16 in here. So you can see we'll get 65,000 IP addresses. So that's a pretty large number of IP addresses. So what we'll do, we'll select this as our IP range. And so here I'm selecting no IPv6, but if you want, you can go with any of the other IPv6 options. Now, you can also name this with some tags. I'm not adding anything specific. I'll just say create VPC. Okay. Now, once the VPC is created, so you can see the VPC is here. Let me jump back to your VPC's link here. What I would like to do is, there is one option I always like to enable. Go to select the VPC and go to actions. And then I go to, let me edit the host names option. And then I enable the DNS host name. So I will let Amazon assign universally available host names for these hosts which I'm going to launch in future for this VPC. So remember that you are in Northern Virginia region. In that you created your VPC, you are setting up options for that VPC. So everything is specific to this. So that we created our VPC now. Okay. So the next step is we are going to set up our internet gateway. So what we'll do here, you see this internet gateways option. You go there. By default, you might have your own internet gateway already created. Here, I don't have anything. Okay. Now, internet gateway is how outside machines or inside machines, which are inside AWS, will communicate with the outside world. So we need one create internet gateway. So we'll go with, let's say, for example, create IWG internet gateway. Okay, so IGW, sorry. Okay, IGW. So here you see there is no big deal, right? You just create an internet gateway, name it, and that's it. You don't have to put the tags or anything, but you don't do anything other than that. So you just create a gateway. Okay. Now for that gateway or for whole communication purpose, we need to create a route table, which will define how each of these machines will communicate with each other. So we'll go to route tables. And then we get the default routing already. But what I'll do is I'll not use that. I'll just create a new one for whole understanding here. So I'll say create a route table, and then I'll name it as, let's say public RT for route table. And then we have to assign it to a specific VPC. Now here we have only one VPC. You could have multiple VPCs. Okay. So for this route table, I'm assigning my VPC. VPC, you can see here my name, my VPC name is great_VPC, but Amazon has assigned a unique name, so I can select that. Okay. Okay. So once I create that, what I can do is I'll just say I created the public route table, assigned my VPC. I say create, and close this. We'll go back to looking at our route tables, right? So here is what we created. This is the route table. This second one was already existing before. I don't want to use that right now. So you see here under this area here, you see the routes option. Okay. So what we are going to do is we're going to edit routes and add some routes to this. And there is, by default, there is one existing. Okay. So we don't want to touch that. But what we'll do, we'll say edit routes. And what you see is this particular thing already exists for the local, and it is already active. We don't have to do anything with that. We just add one more route. Okay. Here, what we'll do is we'll say, for example, 0.0.0.0, which is like anywhere 0, and we'll assign this to internet gateway. So internet gateway. Actually, I need to find my name, I think, in this. Why I don't see my internet gateway? Okay, I think we missed one step here. So go to VPC. Yeah, I did miss that step. When I created the internet gateway, so gateway, okay, here, and gateway is in detached state right now. So what we need to do is select the gateway, and then we say actions attached to VPC. So that's why it was not visible in the previous place. So you can see here available VPCs. You'll see my VPC selected, and you say attach this internet gateway. So basically we attached our internet gateway with our VPC. So you can see here, now the internet gateway is attached to this VPC. Okay. Then we go back to the route tables. We were editing the route table, and what we'll do is select here, and then we'll add, we were adding 0.0.0.0, this one, and we attach it to our internet gateway. We can see internet gateway, and this is our internet gateway. Let me show you again. Okay, great IGW is our internet gateway. Okay, then we say save. Now routes have been edited, and you can see here these two routes are existing right now, and both are active. Okay, so we are done with the route table creation. So route tables are used in such a way that you're going to launch your EC2s in your AWS. How they will communicate with the outside world. So you're creating that rule so they can go communicate with the outside world through the internet gateway. So we created a route table, and in that route table, the default one, we left it there. We did not touch it. We created one more route which will allow the EC2s we are going to launch to go out through the internet gateway to the internet. Okay, so that is where we are specifying, okay, it can go to anywhere it wants, like zeros. There is no restriction. It can go to Google, it can go to any other Amazon services. So we just made it open from EC2 to go out. Well, route table is assigned to the internet gateway. Internet gateway is assigned to VPC. Our EC2 itself will be in this VPC. So it will follow these rules. Okay, so what I did here, if you see this image, right, we selected a Northern Virginia as the region. Then we created a VPC. We created an internet gateway. We created the routing table. So that's all we finished right now. Okay. So routing table looks like this. Basically, I'm telling what is my IP range, and these machines can go to this outside world with these IP addresses. We finished those 3 or 4 steps. Okay. Each machine we are going to launch should be in a specific subnet. So what we'll do here is we'll go to subnets. Okay. And then create a subnet. We don't have any subnets right now. Probably you will have one by default when you launch your account. Now you can name your subnet. I'm just going to call it as public subnet. Okay. And then this is, if you have multiple VPCs, you have to tell which VPC you're creating this subnet in. So I'm just selecting my VPC, which is already previously created. Now availability zone, you can say no preference, or within US East 1, which is the Northern Virginia, there are a lot of availability zones. So here I can just say, you know what, I don't have a preference. Why don't you select the zone for me? Or you can pick one if you want to go that way. So I'm just going to say no preference, like, let Amazon decide where I'm going to go. Then what I'll do, IPv4, this CIDR block. Okay. Now in this, what I'll do, I'll see my range starts from 24.24 that you already know. My public subnet, I'm going to start with 1 as the subnet number. Okay. And then I can put a 0, which is like starts from 0, go up to 255 numbers. But remember that the first 5 IP addresses are reserved for Amazon. We cannot use them. We're just picking up that range, but we cannot use them. Okay. So with 24, like if you modify this to 1 and this will be 24, you can see you'll get 256 IP addresses. 5 of them are reserved for Amazon, so you get 251 IP addresses. Okay. So we do that and then create this subnet. Okay. Cool. So we got our subnet created here. So you can look at the details of that subnet, and if you need to do any modifications there. Okay. Now what we need to do is go to the route table here, and you see edit the route table association. So there is some default entries there. But what we'll do, we'll select this and we'll attach it to our public route table, not the default one. Okay. So let me show you that again. So this is the default one Amazon gave us. You see the name is missing. And then I created my own public route table, right? I'm assigning that public route table to this subnet. Okay. I'll say save. So what we did is we created a subnet. We called it as public route. But remember that by just calling public subnet doesn't become public. You have to allow that route table association, then only it will become public. Okay. One more thing I want to do with this subnet is go to actions, and then how we assign the IPs for these particular machines within this subnet. We go there, modify auto assign IP settings, and say auto assign IPv4, and we'll say as auto assign public IP addresses. Okay. If you don't specify this, by default your machine will have a private IP which is private to AWS, and you will not be able to communicate from your home machine or your office machine to AWS EC2. So that's why we just want to enable this option, and you say save. Okay. And then, you can have your customer owned IPs. So you can use that also if you want. For now, I'm just selecting so that AWS EC2 instances will have the public IP addresses auto assign. So I don't have to do anything extra when I launch my EC2s. Okay. So we're all good here. We selected the zone, we created a subnet, and then we told what is our routing table for this particular subnet. We also specified that we want to get the public IPs assigned when I launch EC2s in this particular subnet. Okay. Next step. So that next step is the security group. Now, as you notice again, as soon as I created a VPC, it gave me a security group. I'm not going to use that security group. Okay, security group is like a firewall. Okay, which will control the inbound traffic now. Now, what I'll do is I'll create a security group, and I'll say security group name is Great Incoming SG. SG is the security group. Okay. Now you want to add any description, you can do that. Like it allows whatever access. Assign it to a specific VPC, and it says description is required. So what I'll do, allows SSH and CAS traffic. Okay, CAS for Cassandra. We have to assign a VPC. We select our VPC. Now, here we are going to specify what are the inbound and outbound rules. Both of them will specify here. So you can see inbound rules are here and then outbound rules are here. Now, there are multiple ways of doing this. You can do it on the screen, or you just create the security group. Don't do anything over there. Go back to security groups and you see the security groups are created here. Now you see what happened. Security group name Great Incoming SG is written here, but you see this name is like empty. So what I'm going to do is just edit this, right? Then I'll just call it as Great Incoming SG, right? So now somehow your security group is named here, and also you are specifying the same name for AWS to recognize it. And then security group has a special security ID here. Okay. Now what we need to do is to define the inbound rules, outbound rules. Two things we have to specify. Okay. Now what we'll do is, first thing, we'll say inbound rules. What are inbound rules are? From outside, how the machines can come inside the inside this subnet. So what we'll do, first edit the inbound rules. Selected this particular, okay, by default it's not selected. Select the security group, inbound rules, go to inbound rules. Okay, I'll say add a rule. Now for inbound rule, what I want is, let's say for example, in this we can select different protocols you can allow. And you can see by default Oracle RDS, PostgreSQL, all these things are by default specified. What we'll do is we'll select the SSH traffic. First of all, from outside world, let's say my home laptop, I need to connect to my EC2 running in AWS. So that is your inbound to EC2. What kind of connection I need is SSH connection. Port number is by default picked. SH runs on 22. Otherwise, you have to pick like custom port for your own custom TCP. So for now, SSH is good. Okay. So you'll say custom. Now where it is coming in from. Okay. Now the best thing to do is your own laptop IP. You can say my IP and it will automatically pick my IP. Or you can say from anywhere. Let's say I'm going to allow all of you to connect to my EC2. Then I can just say anywhere. Okay. Or you can specify the custom range from where it is coming. For now, just for easiness sake, don't do this with any production systems. I'll just say anywhere I'm allowing this SSH connection. Let's say for example, SSH connections is the description. Okay. Then I need a few more rules. One is, let's say, custom TCP. Now, Cassandra, when it runs, it is going to run on 9042. That is the default port. I'm just opening up that firewall, let's say, right? And I'll say from anywhere. So I'm opening my Cassandra traffic to come into my EC2 using 9042 port number from anywhere. So that's what I'm opening up here. And obviously you can say restrict it to specific addresses or my IP address. You can do all that. And then say Cassandra traffic, right? And then you add one more rule. Now within Cassandra, Cassandra has to talk to each other, like because you'll have multiple nodes, okay? And they use something called 7000. We'll look at these ports when we are configuring our Cassandra, but right now we are just allowing these connections to come in, okay? Here again, just for easiness sake, I'm doing anywhere. Do not do this in production or any of your systems you set up. You need to understand how to protect your systems, okay? Now, again, we'll say node to node, node to node traffic. Okay, this is specific to Cassandra because 7000 port is the storage port for Cassandra. Now, these are the three rules I added into my security group, and I'll save these rules. So you can see all these rules got added. Okay, and then we need to add one more outbound rule, and then we'll discuss about these rules. We can just talk about this quickly. So edit outbound rules. There is one outbound rule I want. Okay, what I want is all traffic from my EC2, okay, should be able to go anywhere in the world, like because we want our EC2 to communicate with the outside AWS, from AWS outside world. Okay, so let's say for example, EC2 to outside world. That is what we want it to allow. Now you can say it will go only to my IP, or it will only go to Google, or whatever you want to restrict, you can do that. And you definitely should do some restrictions on your production or when you set it up. So so just a very quick review. What we did is we created a security group. We called it as Great Incoming Security. So in that incoming, we created inbound rules, and this security group is attached to the VPC. So in that we said for SSH, allow all the incoming SSH connections. When you see the 00 is not good because it's coming from anywhere in the world. Anybody can connect to our EC2 with username, passwords, or keys. Private keys are there. We'll talk about that. Now 7000 is the storage port, which is node to node communication in Cassandra. We're opening that up. And then we are also opening the client connections for Cassandra, which comes up. Now, if you just remove this particular rule, nobody can connect to your Cassandra. Or you remove this rule, your Cassandra internode communication will stop. Okay. So we created a security group. Now we'll go into services, EC2, and we're going to say, look at any EC2s which are running. They're not there. I'm just going to create new EC2s. I'm going to launch EC2s. I'll go to the running instances. There is nothing running. I'll say launch. Okay. Now what we are doing is we basically need some machines to run Cassandra. So we are launching our EC2s. Cassandra generally, by default, even if it is non-prod, never ever run with anything less than 3 nodes. That's where Cassandra makes sense only if you have 3 nodes minimum. I clicked on free tier only. There are these options of AMIs. You already know Amazon Linux is basically looks like CentOS or the Red Hat Linux, and this comes with like 5-year support. Okay. So what we are going to do is it comes with some basic stuff already installed. All we need to do is select what kind of OS we need. And I'm just going with the Amazon Linux 2 HVM. You can go with SSD volumes or something like that. More specific when you get to a specific requirement. For now, for this particular session, I'm just going to select this AMI. Okay. Then it gives you options of, okay, whether you need a large machine, small machine. All these are basic stuff you can pick up. Like, say, for example, you need how many virtual CPUs you need. If you go with large, you'll get 8 CPUs. And memory also, you'll get like 32 gigs, EBS storage, and then all that stuff. What I'm going to do is just go with the micro. And imagine this is just a machine with one virtual CPU and 1 gig memory. Very small machine, not suitable for any production loads. Maybe suitable for development, because you're not going to pump a lot of data into the machine. Now, also 1 gig memory is very little. For our demo purpose, this is fine. So I'm going to go to the next is the configure the instance details. Now, how many instances I need? I'm going to launch 3 instances, exactly similar configuration. They're all going into my VPC, which we selected. You remember this, we created our great VPC. That's where we're going. And the subnet, remember we created our public subnet. We are placing it in the public subnet. You see this, we talked about having only 251 IPs and remaining 5 are allocated for AWS. So you can see out of 256 IPs, we got only 251 and use the subnet setting. So auto assign public IPs, we already set up it as like, okay, give me by default, give me public IPs. So you can either use say enable or use the subnet setting, which we already set before. Okay. And then you can say, what is the placement group? I don't want to specify that. Okay. Capacity reservation is open. There are other options like say target by group or target by ID. We don't need to tweak these things right now. We just leave some of this as default. And then what is your shutdown behavior for these EC2s? You just terminate them when you shut down or stop them. Okay, so be careful on choosing terminate, it will be gone when you shut it down. Enable termination protection also you can do accidentally if somebody terminates, it will do some protection, like your storage will be stored and all. You want to watch it with CloudWatch or not? So all this, see for example, this section here, I'm not modifying anything. I'm just leaving it to the default options. Now you can create an additional file system, or you just go with whatever default. There is one operating system file system which comes. I don't need to do anything with that. For Ethernet ports or network interfaces, you can add a network interface. If you want a new network interface, you can say add. And for our purpose, I'm not adding anything. I'll just go with the interface they're providing. One interface is good enough. You can add like secondary IPs and stuff. I'm not doing any of that. That's it. I don't have to tweak anything else. On this screen, what we did, we are specifying we want 3 EC2s exactly configured in the same way. They're going into the same VPC, same subnet, and then we'll get a public IP for each of these EC2s. Okay. Next is add storage. Okay. Generally, Cassandra data and all your commit log files, all those things should go into their own mount points. Here on this particular one, on this particular EC2, we are going to get one default operating system hard drive, which is like 8 gigs. I'm just going to tweak it to, let's say, 12 gigs. Okay, just to show you, there is nothing special. You can add new volumes for your Cassandra volumes. I'm not doing that, but if you need to, just always your production system should have multiple mount points, and your Cassandra should go into those mount points, just like Oracle. I'm just selecting the general purpose SSD for storage. You can go with other stuff. Provisioned IOPS will give you more reliable IOPS. For this particular demonstration, I'm not doing any special storage. Now, delete on termination, you are already checking it, meaning if you terminate the EC2, the storage drive will be gone, which is okay. You don't need to worry about this only for demo purpose. Now tags, you can say tag, these are my Cassandra machines or whatever. I'm not, okay, let's add one tag. Key is, say, machine type. Okay, machine type is nothing but my Cassandra boxes or nodes. Okay, so I just tagged that and then go to the security group. Okay, now here, what we are doing is we have to assign a security group to this EC2. So by default, if you launch without any security group, or you create a new security group, see, it only allows you to do the SSH. That's all it allows, nothing else. So what we are going to do is we'll select our security group. You remember we punched firewall holes for all the ports, different ports we need. So we are assigning that security group and say review and launch. Okay. Now remember that we are going to launch 3 different EC2s for our Cassandra, and it is saying great incoming SG is open to the whole world because we allowed incoming traffic from all entire internet. Okay, so you can review all this. I did not add any special storage. You can look at the instance details. You can look at storage details and any extra tags we created, and we just click on launch. Let's talk about this key pairing. Now, without this SSH key, we'll not be able to connect to our EC2. So do not make any mistakes. Here I'm going to create a new key, and then you can call it anything. Like, say, for example, I'll say AWS, my AWS set key 2020. Okay. And then you download the pair first. You know, we don't want to miss downloading that. So you got a PEM key here. Show me in folder. Okay, so you can see here in one of my D drives, I created a VMs and AWS keys in there, and this is the key we just downloaded, new one. Okay, so I'm going to get rid of the old one to avoid any confusion. This is the current key, and this is a PEM key, which is the private key. I think this is the private key. Public key is stored in AWS. Okay. Now, without this key, we'll not be able to connect to our EC2. So remember to just either you create a new key or make sure you have a key stored already. And then you can then launch your instances. Okay, let's click on launch instances, and then we'll talk about one thing here. We'll use Notepad++. And once that comes up, I'll just bring it to this side. Okay. And then I'll open this PEM key, and that's how it looks like. Okay, so it's a RSA key. Basically, it's an encrypted string. You can see the key file looks like this. No big deal. Do not touch it, because if you modify anything, that key gets corrupted, and then you will not be able to connect to your EC2s. Okay. I'll just go back to my. Yeah, go ahead.
Only one question is like, I heard like if we lose that key and you can't recover that key. That's
yeah,
it.
there is no way to re-download this key. So that's where you have to keep like multiple copies if you need to.
Okay, so we need to rebuild our EC2 machine again?
Correct. You need to just terminate. You cannot connect to that. Yeah, it's a total disaster if you lose that key. So just be careful.
Okay.
Okay. Now, If you look at my EC2 list, right, I go back to the dashboard, I go back to running instances. I have 3 instances running. It's doing some initialization on the status checks. Now, while it is doing all that, what we can do is we can name these things. Okay. So by default, there is no name assigned. I'll just call them as CAS1, okay, and CAS2. Now, I just don't care what is the order. I'm just naming them in that order, whatever the order I see. And what I'll do, I'll go to the CAS1. Okay. Now, remember a few things here, right? One is, where is my notepad? Okay, here. So what I'll do, CAS1, and let's say this is the machine name. Okay. And then IP address, I'll just have public IP. And then each AWS machine also comes with a private IP. Okay. Now there are a few things I need to mention about the IP addresses, but let me first make the sheet. Okay. The second one, third one. Okay. Now public IP will change with every reboot or restart. Okay. Remember this particular thing as your mantra. Every time you restart your machine in AWS EC2, public IP will change, will not change. Okay, private IP is assigned for its life. It's not going to change. Remember these two things. Okay. Now what we'll do here, go to the Amazon console, click on that EC2 CAS1, and you see the public IP listed here. So we'll copy that, save it here. Okay. And then we'll go to the second one, copy this, save it here. And then go to the third one, copy this and save it here. So check one thing here. So if you see, all these 3 things came out in a different network. And that's really great about Amazon, because you're not managing any of that. It just gives you a public IP and you don't care where it is. And private IPs will obviously be in your 24.24, 24.24.1. Remember that was our public subnet range, right? So next step, our EC2s are running. What do we do next is we have to connect to them. So you can see here 2 checks passed. Everything is ready on our EC2s. We are now ready to connect to our EC2s. Okay, so here it is. What we were doing is we launched our EC2s. We were talking about MobaX term. So I'm going to create SSH connections to my EC2 machines. So I'll take this public IP. I'll just take only the IP address and put it on MobaX term. And then all EC2s, by default, they allow us to connect using EC2 user. EC2 user is the username. And obviously, we need to use our private key. Remember, we got a key from Amazon. So we are going to specify where our key is. And I'm just using another screen to load that key here. Okay. So you can see I specified where is my key, and that is the PEM key. And SSH port is 22. That's where I'm connecting with this. And then any other information you can modify and then say, okay. So you logged into the EC2. Okay. What I'm going to do is I'll just duplicate this particular session 2 times and then change the IP addresses. That way we can connect to all 3 instances. So I'm just going to go get the second IP. And here is my second IP. And then paste it here and then modify the link. Oh, you know what I'll do? I'll just call it as CAS2, second one. Okay. And then I'll edit the third one and then change the IP. We have our public IP here. And then CAS3. Okay, I'll call the CAS first machine as CAS1. Okay, so all three of them we specified to use our key to connect. Okay, there are a couple of things we'll do. We'll right click and connect to all the sessions. Okay, so you can see we logged in successfully into our EC2s, right? All three of them. So let's see a couple of things we have to do here once we are on EC2 machine, right? We downloaded and installed our client. You can use any client you like SSH wise. Only thing is you have to provide that PEM key, which is the private key, and public key is already stored on Amazon, which will allow you to connect to your EC2. Okay. So before going into OpenJDK, right? What we need to do is we'll just customize our EC2s a little bit. So what we'll do, so we are connected as EC2 user. Okay, so all three boxes side by side. Okay, so MobiXterm has this option called multi-execute. So you are connected to three servers. You can type commands on all three servers at the same time, like this. Okay. Who am I? Will show you that you're connected to EC2 user. So what we did so far is we created all the infrastructure in AWS. We have our three EC2 machines running, and we logged into EC2 machine as a EC2 user. This is the default user. Now you do get option of running sudo commands, sudo like this, sudo su minus. Let's say, for example, you want to become root user. You can do this and you became a root user. So you can see on your EC2, you are a root user now. Okay. What I generally like is there are a couple of things I usually like to do, very useful shortcuts for myself. You don't need to really do this. I'm just going to add two aliases into my bash RC file. And what I did here is, if you notice, I just added two aliases into my etc bash RC. And what happens from now onwards is I can clear, exit, and you can see, like, if I re-log in, and now onwards I can just do simple two aliases I created were L is for listing, long listing, and D is for telling me how much is occupied in that folder. Storage wise. Okay, so those two I always create as the small links. Okay. Next thing is, okay, for Cassandra to run, we need two softwares. One is Java, because Cassandra itself is developed in Java and it runs in JVM. And then the second one it needs is Python. So Python by default comes with the AMI, and you can see Python 2.7.18 is already pre-installed. But when you do Java minus version, usually it will give you this error because Java itself is not pre-installed. Okay. So what I'm going to do is I'll just say sudo su minus. Okay. And what we need to do is to install OpenJDK. Now, OpenJDK installation, okay, before we do that, we look at our slide, has the command in there. Okay, we can use the yum install, and we'll just install JDK. We are not using the Oracle JDK, we are using OpenJDK. Okay, I'm going to hit enter, that will install Java for us. And I'm doing that as a root user. So when you set it up as a root user, the entire machine, any user logs in, they can use the Java on this machine. Now remember that your EC2 or the virtual machine at home, it needs to be able to connect to internet to bring all these packages down and install them. Okay. Now if we do Java minus version, you got your Java installed. Okay. Any user on this machine now can do Java minus version. That is, any user on these machines can run Java. Okay. So we know that Python is already there. Python minus capital V. So you can see Python is already there. Java we got pre-installed, installed. So all our prerequisites are now in place. Next step, we need to make sure the folder we created, apps opt Cassandra, that's the home folder for Cassandra user. We need to make sure the permissions are set properly. So let's talk about these permissions for a second. What are the permissions we need to set and ownerships of the folder and everything. So first thing on this line, if you see what I'm doing is I'm making the Cassandra user as the owner, with the group will be Cas group, and that we are granting privileges on the created folder, the home folder. First step. Second step, I'm removing all the privileges for the others on this particular folder recursively, and then we set up like, you know, group can have write privileges, a group cannot have write privileges, group has only read and execute, and then for user we are granting all read, write, execute on the folder. So once we run these, we are just setting up the folders properly. So Cassandra user has full privileges on the mount point. Now you could actually attach it as a separate storage. You can have multiple storages for Cassandra. On this, we are just basically following a very simple, imagine apps opt Cassandra is a mount point, and you're granting all the proper privileges for the user. So Cassandra user can log in and use that folder. Okay. Now, from my local box, I want to connect as Cassandra user, and that is not possible. You have to first, store your key on EC2 box. So we are going to talk a little bit about SSH keys. What I'm going to do is, if you see here, so I just came out and became the EC2 user again. I will do su minus Cassandra. Cassandra user already exists on this machine. I can give the password. We selected the password in the beginning itself while creating the user. Let me make sure Cassandra user exists. Okay. And then sudo password for Cassandra user. I will specify the password. Okay. So we are trying to log in into Cassandra user here. Su minus Cassandra. Oracle is the password. Okay. So previously login failed, but here you go. I'm now a Cassandra user, and you can see that I'm logged in as Cassandra user. Okay. Now ls minus lha, you can see there are no folders, subfolders. What we need to do is we want our local laptop or the desktop at home to connect to this particular user, Cassandra user, in our EC2 box. The way we can do it is, there is something called authorized keys file, and in that keys file, we have to put our key. So what we'll do, we'll go back to EC2 user. Okay, I'm back on my EC2 user. And if you look at this folder called ssh.ssh, okay, this folder has a file called authorized keys. Now this authorized key is same as your key you got in the PEM file. Okay, so what we'll do is, all three boxes have the same file. You see this way. Okay, what I'll do is I'll just make a copy of this, and I'll just go here, paste it. Okay. Now with Cassandra user, we are going to create this file and then put the key in there. That way we can connect from our desktop or the local laptop to the EC2 using Cassandra user. Okay. So what we'll do is first we'll have to generate SSH keys. So SSH keygen tool we can use. Okay. Right now .ssh folder is not existing. We are just creating SSH keys, which are private and public keys on each node. Each node will have their own key. Okay. Now here you can read through the things and you can enter different values and all. I'm just selecting all default. So I'll just keep on giving enter keys until it is done. Okay. So this is done. So what I can do, ls minus lha, you can see this folder got created and only user has read, write, execute permissions. Nobody else in the world should have access to this SSH keys. Okay. So I did not create the folder. SSH keygen command created it. So now I'm going into the SSH folder. You can see what is in here. You can see there are two files. One is a IDRSA, which is the private key, which does not have any extension to the file name. You should never expose this because it's a private key for the server itself. Each server has its own keys. They're not same. And on the other file, which is the idrsa.pub, that is the public key. And that public key is public to the world. You can distribute it only with a combination of the public key, private key, they will be able to log in. Okay. So all that is good. We created our public keys, private keys. What we'll do now is we'll copy the key from one node to the other node. Okay. Now, one way to do this is just we can, cat id.pub, idrsa.pub. And you can copy paste this into that authorized keys file, or you can use SSH copy command, copy ID command. Okay. Now, our public IPs, they're here. So let me go back to our notepad we have. So these are our public keys. These are our public keys. And we did not capture our private keys yet. Private IPs. I'm talking about IP addresses, not the keys. Okay. If we do ifconfig, let me actually run it only on one node. You can see that ETH0 is the network interface assigned to us by Amazon to the TC2. And this has something like 24.24.1.206. So this is our private IP address assigned to the EC2. Okay. So each machine will have a private IP assigned. So let me grab these things and put it in our documentation here. So remember I told you about our network is 24.24.1, and then the IP address is assigned by EC2 or Amazon. So for the second box, this is our IP address, and the third box will have its own private IP. So these are the private IP addresses. And also, while we were on a break, I updated something here. So public IP will change only with a shutdown, okay, not with a restart. If you restart the box, public IP will stay same. So remember, if you shut down, it will completely go away and come back with a new IP. Okay. So what we are doing is we are just getting that public key from each box, and I just pasted them here. And you can see here, these belongs to the three different boxes. And this is the public key string. And also we have one key, which is our own private public key. Okay. This is the AWS key. So there are 4 keys here in the authorized keys file. Okay. Now, what I'll do is I'll just say vi. You can see we are already in the .ssh folder. Okay. Vi authorized keys file. I'll just copy the name from here instead of typing. Authorized keys. In this authorized keys, I'm saying all these 4 servers can talk to each other. Okay. So I inserted that. Okay. And I can say WC minus L. There should be 4 keys. 5th one is just a blank line in there. So we have added our keys. Make sure this file does not have privileges for others. So let me just say, for example, LL. So you see this authorized keys file will change the permissions. Okay. chmod, only user should have read write. Everybody else should not have. Group and others should not have read on authorized keys file. Okay. So you can see now authorized keys file is only available for the user. Same thing with the private key, only available for the user. Group or others cannot see these two files, content of these files. Whereas the public key is public. No problem with that. Okay. I just disconnected from EC2s. I will just use one of these users. I'll just edit Cas1. I'll make it as Cassandra user. Okay, so I'm directly going into Cassandra user on the first box. Let's see if it connects. Okay, what we did is the key we specified in the authorized keys file, we put our own key, which is our EC2 key. Okay, so that's the reason we are able to connect directly here. So if you see what we did here, so the first one itself is my my key, right, which I got from the AWS while creating EC2s. We got our key, and then all the other three are from the three different EC2 machines. We kept everything on the authorized keys on all three nodes. Now, obviously, we need to connect between the servers, right, to just check if the SSH is working between the nodes. And we can use it. This public IP will not work, but we'll use the private IP to verify. Okay, so I can do SSH private IP and run this command. Let's say, for example, date hostname, and it's asking me, are you sure you want to connect? I say yes, and then it's able to run that command. Let me do that again. So remember, we put the public keys of all three servers on each other, so they're able to talk to each other. Okay, that is the passwordless SSH configuration. We can try this with the second IP for the second node, and it's asking me, are you sure? Yes, and then you can run it again. You see the second node is also responding. Third node. Okay, so all three nodes we are able to connect from my local desktop to EC2s using Cassandra user because the key is there. And then all nodes are talking to each other without password because those keys are also exchanged. Okay, remember to protect your SSH folder. So ls minus lha. You see SSH folder is protected in such a way that only user has read write execute permissions. Nobody else should have. Okay, if anybody else has any privilege, then your SSH itself will not work because that's how the security is implemented on SSH. Then you go into SSH folder, you have three files, authorized keys, ID RSA key. These two files should be only available for the user on each machine. They should not be available for the group or others to read, write, or execute. Then you have this ID RSA public key. Only current user will have the read write. Everybody else can read. Known host is created by default when you say, okay, I'm able to connect to that other box. So you say, okay, yes, connect. You're giving permission to connect. It will identify that remote host and write the information into known host file. You don't have to edit the known host. You only deal with your private key, public key, and the authorized keys files. Now we have set up a passwordless SSH between these three nodes. So let's talk a little bit about this partitioner. So you see the partitioner is a murmur3 partitioner, and this is the default partitioner in Cassandra. They used to have something like random partitioner, byte order partitioner. We are not using them. They're there just for the backward compatibility. Right now, by default, Cassandra comes out of the box with a murmur3 partitioner, and that's what we are using here. Okay. I just mentioned it. I'm not changing any setting there. Now, we'll keep scrolling down a little bit. You see on the line number 193, let me do one thing. Okay. So you see line number 193, it is giving you an option to specify data file directories. Okay. So let me discuss a little bit. If you see here, it says hints directory is this particular directory name, right? For data file directories, you see the setting is a little bit different. You see data file directories, it says multiple directories. So you could have like mount points like this. Say for example, U01, okay? U01, very Oracle type, right? And then you can have U01, 2, 3, 4. Each of this could be like SSD1, SSD1, SSD2. You might have attached like, 4 different SSDs. Now for data file directories, you can have multiple mount points, and like, you have a mount point U01, which is sitting on the SSD1. You can have multiple data file directories. Cassandra will automatically distribute the files across all these 4 disks. It will load balance the file sizes and all that. So right now, only thing you're specifying is where your data files go. And I'm just using one folder for that. Okay. So you can see here, and I messed up one small thing. If you notice here, see the tab. So this tab is not good. It will create problem for us. Okay. So what I'm going to do is, instead of typing, copy pasting, I'm going to yank 2 lines here and then edit them like here. And then I will just make an entry, copy from location here. Okay. You do it multiple times, you'll know there are some issues with this YAML strict settings, like, you cannot miss any spaces, you cannot miss any extra tabs. So you have to be a little careful with all that. And then you scroll a little bit, you're telling where is your commit log directory. So next important parameter, what we are saying in the seeds parameter is, let's say when you are adding another node, a new node into your cluster, it should ask somebody, say, hey, what is this cluster? What is the size of the cluster? How many nodes are there? How many tokens each node is handling? Where are they located? Which data center, right? That information needs to be provided by somebody who is already existing. Okay. So in this case, who is the seed provider? So that is the information we want to provide here in the seeds information. Now, remember, we are running it in EC2. So there is like public IPs, private IPs. There are so many different things. You should not leave the seeds to be local loopback adapter. So what we'll do, we'll specify the proper seed based on our AWS configuration. So give me 1 second. So what I'll do is I'll specify seed information to be public or the elastic IP in the EC2. Okay, so what we'll do is we'll go back into this. So you see seed provider should be written like this. Okay, so what is our IP address here for the public IP? If you look at our public IP we have for the node 1, this is our node 1. Okay, remember this seed is used only when the new node is being added to the cluster. Okay, and you should have 1 or 2 nodes specified as seeds. You should not have more than that, because let me put this here and then explain it for a second. Let me comment out the existing value. I don't want the existing value. I want to add a new entry, and new entry is written as from our text file here. So this insert, okay, that is the seed. Okay, let's talk about seed a little bit. If you have 800 node cluster and you're adding the 801st node, you don't want that the new node to talk to all the 800 nodes, right? Because it will go there and say, hey, all of you 800 people, give me information about this cluster. You don't want that to happen. So you want 3 or 4 nodes act like seeds. So you never add all of your nodes as seed nodes. Remember that part. And seed is only used when you're adding a new node to the existing cluster. So here in this case, I'm just specifying the current node public IP as the seed address. For the first time when it is starting up, this particular node, there is no cluster. So it itself is the first node. So it is going to create everything. And the second node will use this as a seed node. So second node will say, hey, why don't you tell me about yourself, right? Any new node, when you're adding to the cluster, that process is called bootstrapping. So during bootstrap, that new node will go and talk to the seed and say, hey, can you tell me about this cluster, right? So that is the reason we set up this seed. And I explained why you should not be using all of your nodes as seeds. Like say, for example, if you have a 100 node cluster, 101st node, when it is joining, you don't want that to talk to all 100 nodes. So you will only give like 4 nodes as the seed nodes. Okay. So then the next thing is, how does this node talk to, where does it listen, right? So there are 2 things here. What we need to do is, we need to understand what is your listen address. Listen address localhost means 127.0.0.1. We don't want it to listen it on that port. So either you can mark this comment out, and then you can specify your private IP. And let's say, for example, private EC2 IP, right? Or you basically comment out this whole thing and then use something called interface. Okay. What does interface mean is, each node came with the ETH0, right? ifconfig will show you each node has ETH0. So whatever IP address is assigned to that ETH0, I don't care if the IP address changes, just use ETH0 for my communication. Cool. So I'm setting up listen interface. Now, what it means is, if at all your private IP changes, your network changes, whatever changes, it knows how to bind to that particular IP address. So we are just binding it to the interface, not the IP itself. Cool. Yeah, same way there are some more parameters, like say, do we prefer IPv6 communication? What is the broadcast address? You can read through all this. There are a lot of optimizations you can do, but I will touch upon the most important ones you need to know. One is called start native transport. What it means is, basically you want your clients to talk to your server, they should be enabled. And remember, in a cluster, you can have 4 nodes in maintenance. Those nodes will not accept any client connections. In that case, you can change this parameter to false and start the node again, restart. That means there onwards, that node which is under maintenance will not accept client connections. So that is the start native transport, yes or no. Okay. For now, I'm just going to leave it in the default start native transport, yes. this is telling, okay, so let me do one thing. I'll just put it here, right? And then I'll make it like, okay, false. You can have only one setting, obviously, right? So if at all you have a maintenance going on one node, okay? So what you can do with this setting, if at all you set up this setting, right? It will allow clients to connect to the node. This is node specific, you remember that, okay? Now, if at all you are using this setting, like say if you are under maintenance, then any clients which are trying to connect, client connections will be rejected by this node, okay? Obviously, you can have only one setting per node. So by default, we are going to start our native transport. By default, yes, we want to start that. Now, all clients will use this port to connect. So remember, we punched a hole in our security group so that clients can connect to this port. 7000 is the node to node, which is inter-node communication, and native transport port is the client to cluster communication. Okay. So we did not change anything, but we tried to understand what is the stative native transport and what is native transport port. Those are the two things very important to understand. Okay. Now, there is something called RPC, remote process communication. Okay. What they used to do is Cassandra had something called Thrift RPC server. Okay. This Thrift is nothing but it's an Apache project. If you look at Apache org, okay, apache.org, sorry, apache.org, and look for all the projects they have. Under that project list, there is something called Apache Thrift here. This is the Apache Thrift. If you go here, you can see Thrift. So you can read through this. This is what they thought is the Thrift is one protocol. Basically, they want to have a common language between all platforms and they can communicate with each other. Okay. So Cassandra used to support Thrift. And then they said, you know, not a lot of people are using it. So they removed Thrift from the product. And by default, you see start RPC is false right now. And in future versions, they're removing RPC support completely. So Cassandra in the olden days used to support something called Apache Thrift. Thrift is a protocol where it is a common platform for other softwares to talk to each other. And you could connect to Cassandra using the Thrift protocol and do your queries. Then later on, they noticed that the lot of clients are not using this Thrift. And they said it's a dead weight on Cassandra product. So they started de-supporting it. So right now it is not completely removed from the product. Instead, they just disable it. You can see that on line number 687, we are still talking about cassandra.yaml file. Start RPC is by default set to false. We don't change it because in 4.0, this is completely going away. RPC will not be there at all. That will be completely removed. But for now, for this 3.11 version, we just leave it in the RPC equal to false. We just want to make sure we understand what is RPC. We leave it in its own original false state. And one thing we want to change here is see this RPC address, just like our listener address. We will use the interface instead of address. Okay, I'll change it to ETH0. So RPC interface is changed to ETH0. And if we were using RPC, what is the clients will connect using this RPC port number 9160. Right now, because RPC itself is not running, we don't have to open this port. We are not going to enable RPC for anybody. So it's just there for our understanding. We know what is RPC. It is not running, and this is the default port for our RPC. All good? So then the next option we need to look at is endpoint snitch. So in the snitch section here, which starts at line number 913, you see there are a lot of snitches: simple snitch, gossiping property file snitch, and property file snitch. And then there is a EC2 snitch, EC2 multi-region snitch. What I'm going to do is just, we are talking about this snitch here. What I'm going to do is just make a note here. Okay. So I'll say this is the correct snitch for on-prem Cassandra. Okay. On-prem meaning your on-prem hardware in your company or wherever. Then this is the correct snitch for AWS EC2. Okay. So that's noted down. So for us, we are on EC2. So we are going to use EC2 multi-region snitch. That is the snitch we are going to use for this setting, this particular configuration. Okay, all good. Now, snitch is a module which gives knowledge, or it knows everything about the network, and it provides that knowledge to Cassandra cluster. Okay. For now, that's all we need to understand. And because we are going to use EC2 snitch, so I'm going to specify here. See, there is one more called rack inferring snitch. There is another snitch called Google snitch, Google Cloud snitch, and there is like Cloud Stacks snitch. So there are a lot of snitches which are each environment will provide. It's a module which you plug in to Cassandra, and Cassandra will suddenly know about everything about your network. So right now we are plugging in EC2 multi-region snitch. We are saying we are running it on EC2, so use this snitch. Okay. What I'll do now, so for example, if you look at this file here, rack DC properties file. If you're using gossiping property file snitch, most likely you're running your Cassandra on-prem or your local laptop or desktop on virtual machines, not on cloud, then you have to edit this file. Okay. What does this file contain? If you just do a cat Cassandra rack DC properties, this file contains two entries. There are only two entries which you need to modify. This one, DC1 and rack1. What you're telling is, where is your data center? Okay. So let's say we'll edit this file, Cassandra rack DC properties. Whether we save it or not, I'm just going to go here. You know, I don't like to edit the original file. So I'm going to comment out the entries. And again, this is not a YAML file. If you notice, it's just a key value pair. Now, your data center can be East DC or let's say West DC, right? Whatever is suitable for you. Or you can completely have a virtual name for this. Let's say, for example, this is your OLTP DC, meaning all the nodes in this data center will participate in online transaction processing. Or you can say, for example, analytics DC. Okay, this is virtual name. You're grouping your nodes into data centers. Okay. So let's say, for example, we'll just pick West DC for this. Okay. So I'm configuring a node in West data center. Now, you know that in West data center, you have a location for this data center. Let's say, for example, you are in building 1, you are in floor 3 or 4, and then you are in room 25. In that room, you are in bay 3 and rack 1, okay, physically. So you can specify something like this. Now, this is for you as an admin, you know where physically this server is located, right? Not only that, Cassandra itself, because you're specifying where your nodes are, let's say, for example, your node 2 goes into another rack. Okay. So let's say, for example, this is on the node 2. This is node specific configuration. So this is in building 3. Okay. Let's say everything else is same, but it's in a different building. So Cassandra now, when it keeps copies of your replicas, it knows that you have to keep, not all replicas should go into building 1, because if at all building 1 crashes, let's say it completely collapses, your data is gone. So Cassandra, what it does is it tries to distribute your data, keep multiple replicas in different buildings. That way they're safe, right? Even if building 1 collapses, building 3 is still there. So it can read that replica from the other side. Okay. So this particular file is node specific. And remember that we are in a EC2. So this file will not be used. It's only for on-prem databases. But EC2, it's the Amazon itself will provide that knowledge of, okay, you are running in the Northern Virginia region 1, and you are in availability zone 3, and all that information is provided via EC2 snitch. And then what you do is next step, okay, it loaded all those parameters and it did something. I will notice, I'll tell you where you should read properly. Is you see this, the snitch is set to EC2 multi-region snitch, and it went and asked EC2, hey, where is this EC2 running? It's in US East and zone 1B. This information came from Amazon because of EC2 snitch. Okay. Then it did set up something like public identifier. You know, this is our public IP. So EC2 snitch gave this information back to Cassandra saying, okay, this is the public IP. And then it did something with the JMX, some other stuff like class paths, stuff like that. No tool status. Okay. Here, what you notice now is your data center, US East, which we did not specify. Remember that this came from EC2. This came from Amazon. Amazon is telling that you're on a data center, US East 1, US East. Okay. This is because of the EC2 snitch. So this is the host ID it created during the first time. And then where is the rack? That is nothing but the availability zone in AWS. I want to mention one thing, because we are on EC2 and we are not using the elastic IPs and stuff. When I shut down my nodes, I just completely shut down the nodes. Public IPs will change. Yeah, so your public IPs will change, meaning these settings. You have to change your SSH configuration. So you go to the new public IP. And then inside the configuration files in the Cassandra config file, let me just say cat conf folder Cassandra YAML grep seeds.
Okay.
Okay.
And this IP address will change.
So this public IP has changed after you reboot, right? So you just have to specify the new seed address only for the first node. Now, one thing you can do with this is you can have the elastic IP for the first node, and then you will get a fixed IP. But remember that AWS charges for elastic IP.
Yeah.
So then you know you can have other nodes point to that elastic IP, and that will be always there for you.
But if I bring second node, third node, again I need to change their entry, right? There also.
Seeds entry.
Yeah, seeds entry I need to change, right?
Yeah. Even though they're not bootstrapping, they're just joining back into the cluster, like if they're just coming back. They're not like bootstrapping anything, but they still need to know where to go for, like, you know, are you there or not? Like, you know, thing like that.
Yeah.
Now, this is very specific to EC2. On your on-prem, you don't have these IPs changing all the time, right? They're static IPs. So EC2, you might have to use elastic IP.
Yeah, but we need to change in the YAML file on 3 nodes.
Correct.
Okay.
Well, first node, you don't have to, because first node itself is a seed.
Okay.
Yeah,
Okay. And
self-address
second
is
and
not a big deal.
okay, self-address is not okay.
Yeah, if you want to generically say, then you change it on all nodes.
Okay. Yeah,
Yeah,
makes sense.
yeah. So let's just go to cassandra.apache.org. Okay, this is where you go for your Cassandra software. All the documentation is listed here. So if you go into beta 3, this is the documentation. And you're looking at 4.0 documentation. So you might want to switch to other versions if you're looking for specific version based documentation. There is another way to go to the documentation is you go to DataStax, and also DataStax also maintains some documentation. There are places where they use the open source documentation and then they switch back and forth. So you go to almost to the end of the screen, you will see this get help on the DataStax, go to docs, and you can land up here. Now this one has both DataStax enterprise documentation and open source Cassandra documentation here, docs for Apache Cassandra. And I did click on that. What happened? Okay, I click on that. So you see this documentation is listed here, and you can see the older versions and also driver documentation, all that stuff is listed here. So keep this handy. You know how to read the documentation if at all you need to look at it. So you see this is the latest version, but let's say if I want to the older version, so you can go to doc and then go to the specific version, let's say 3118, and then you can browse through the documentation specific to the version. Okay. So how I got there is I just remove this version here at the end of the URL. And then you can pick whatever version of, see, alpha 4, beta 3. As I said, beta 3 is coming up, but you see the documentation is already up here. Okay. So you can go to specific version, but you can check in the URL itself. It tells you which version you are browsing. Okay. So that's about the documentation part of it. So first thing we'll check node tool. First of all, node tool status, right? So let's check it only on one node and see what status it is. All nodes are up and running. No questions about that, right? Clear this whole thing and say node tool version. See what version of Cassandra is running. What is the version?
Yeah, 11.6, 3.5.
311.6, okay? Okay.
Yes.
Let's go back to our installation part. What did we do is we downloaded software which was stored in software folder. We created a bunch of folders. We extracted the software. We created a soft link. We created conf file, and we copied the original configuration files into this folder. And then we started Cassandra, right? Adding nodes after the configuration files are modified. Correct?
Yes.
Okay. For upgrade, you see this 3116, we were following all the best practices. That's why your upgrade will be easy. Okay. What I did is I downloaded the software already, and the new software is 3118. Remember, this is a patch release. Okay. So we got the 3116 version, same major version, minor patch. When you're moving from 3 to 4, there are some changes because they deprecated a lot of options. They might have changed some parameters. They've changed the architecture. But in general sense, upgrade should look like this. Okay. First thing I will do, I'm going to go back into my home folder. This is where I am. I'm going to tar minus xzvf, nothing special, right? Software, Apache Cassandra, new version. No questions about, right? That is just extracting the software. And we'll do that on all nodes, just extracting new software. Okay, no questions? So you got now two softwares. One is your 3116, which is currently running, and 3118, new version. All good?
Yep.
Your data is in central location. Your configuration files are in central location. So you don't have to touch them, okay? What I want to see is, see, originally you got a configuration file and you modified something, right? So where is your configuration file? Con folder and Cassandra YAML file, correct? This is the main configuration file. Same way, Apache 3118 also comes with a configuration file, Cassandra YAML, okay? So these are the two files. One is your current configuration file you're running with. This is the new configuration file, okay? Let's check file diff, because you want to see what are the file differences between them, okay? So I think it is not the file diff, but it is just the diff command. So I'm just checking if there are any new parameters added in the new version, okay? So you can see cluster name was changed, token number settings were changed, because we customized our configuration, okay? And then we have hints folder, password authenticator, and other stuff, okay? And then some more folders for commit logs and saved caches, seeds, all these things we know, right? Listen interface, RPC interface, and then we have like endpoint snitches we changed. All good? In the new version, I see these entries which are all commented out, okay? And there are some parameters which are uncommented, but these are all new in 3118 compared to 3116, okay? So nothing big has changed, but if there is big, then you have to merge configuration files and make sure you have a new configuration file. All good?
So when we are upgrading, the cluster needs to be down, right? Application needs to be down.
No, hold on. We haven't got there yet. First understand there is a difference or not in the configuration files.
Okay.
Okay.
I thought that is not
Yet,
part
not
of
yet.
discussion. Okay.
Not yet. No, we discuss, but not yet. So all good. We know that configuration files look similar. There is one small difference here and there. We don't have to worry about it for now. But you take the new configuration file, merge your settings into there, and then your configuration itself is done. How do you configure any new cluster, right? You update the conf file. All good? Once you have the conf file, you can make the copy of that conf file to other nodes. Right now, I'm just not showing you how to do it because you're just modifying your conf file. In my case, my configuration file is already in the conf folder and I'm going to use it, okay? What we did next step is our current node and current cluster is running this version using this soft link, okay? What I'm going to do is one node at a time, okay? So you can see one node here. I'm going to node tool. So let me clear screen. Which node tool? You can see it is using that soft link we created in the day one, okay? I will say node tool drain and node tool stop daemon. Any questions about that? I'm just stopping my Cassandra on this node. So I'm shutting down my Cassandra. That is what the sense of the two commands is. Okay, done. On the node 1, if you look at the status, node 3 is down. Agreed? I'm going to remove this soft link. Okay. Cassandra itself is not running on this node. What I did was I just shut down Cassandra, RM this soft link. Okay. So I removed the soft link, meaning I was pointing to 3116 before, but now I'll create a new soft link pointing it to the new version. Any questions so far? I will just call it as Cassandra and then look at the soft link. So it's just pointing from here to here. Okay. I can do one more thing. Actually, I will not do it this way. I will do a soft link with the full path. Okay. ln minus s and then apps opt Cassandra Apache Cassandra 3118, and then I will call it as apps opt Cassandra. Okay, you can see the full path now. Cassandra points to new folder. All good? So what we did here is, earlier this soft link was pointing to old software. Now it is pointing to new software. Nothing much, right? Simple?
Yes.
Okay. Then if I do which node tool here, which node tool, now it is pointing to the new folder. If I run Cassandra, it is starting with the new version. Okay, we give it a minute. It starts. So it's handshaking with the cluster nodes, other nodes and all that. No gossip, backlog, proceeding. Okay. Now if you do node tools status, you can see that node came up, part of the cluster again. Node tool version, it is running with the new version. Upgrade completed on one node.
We don't need to update like metadata or something.
Yeah, good question. So what we'll do, we'll first document what we did here. Okay. So part one, we did node tool drain. Okay. Before that, node tool, I'm just typing the command stop daemon. Okay. But before that, what we did is we did cd, go back to my home. Okay. tar minus xzvf software slash, we got the software in the software folder. So we got the new version. So that's what we are extracting. Okay, RM Cassandra, which was the soft link. Then we create a new soft link. Okay, before we remove that, we actually shut down Cassandra. And then soft link apps opt Cassandra. This is your task plan, okay? Which you spend 6 weeks with your application team for Oracle. Agreed?
Yeah.
And then you start Cassandra. Okay, so this is your task plan. To upgrade a node, you go to your home folder, extract your software, shut down the current running Cassandra, remove the soft link, create a new soft link pointing to the new software version, start Cassandra. Okay. So just
this is how like downloading the README file and reading the instructions, implementing.
Exactly. So I'm actually going to do that here live for you. I just copy paste that commands here. Okay. Apache Cassandra. And this is my production cluster. Okay. So there is no big difference between production or non-prod. VI upgrade Cassandra.sh. Insert, put those commands. Anything you want me to say before we run this?
No, you told right you are in production. Why?
Yeah, I'm running it now here live. Watch it. Have fun. So it's extracting. Now it is shutting down. Okay, shutting down the node. So we'll check that it is going down. So you can see here, second node went down. And then it is actually starting up again with a new version. Okay, done.
Oh, can you show the commands once?
Yep. So these are the commands I copy pasted. Go to my home folder, extract the software, shut down Cassandra, remove existing soft link, which was pointing to old version, create a new soft link pointing to new version, start Cassandra.
And start the Cassandra.
That's it.
Okay.
Okay. So now if you do node tool version, you're running with new version.
Okay.
Any questions here? Let's do the last node also. Then we'll see if you get excited. Okay. Here, I am going to, you know that I love SCP. Okay. Eternal 2, that is the server I want it from. I want it from my local. Okay. Get me that upgrade Cassandra script. Put it on my first node. Okay. Put it on here. And then I will remove this already extracted. I already extracted the software earlier. So I'm just removing it. Okay. So sh upgrade script. You took 6 weeks Oracle planning. Okay. This is not even 6 minutes here. We upgraded 3 node cluster. Any excitement, please?
Yeah. Lot.
Yep. Okay. So what we do now is you make sure all your nodes are up and running. Okay. So you check node tool status. All nodes are up and running. Node tool version shows you new version on all nodes. Agreed? Okay. So we did this on one node at a time on all nodes in cluster. Okay. Done. Update.
So there will be no downtime.
No downtime. Already we did a rolling update. Update metadata. Okay. How do you do this is on one node at a time on all nodes in the cluster, run a command called node tool repair. Okay. But
Wow.
as I said, you're going to run this on one node at a time. That means you can schedule it to run like slowly overnight. Nobody is impacted. It slowly runs in the background. My cluster is not big, so it will run. What it is actually doing in the repair part is it is just going to upgrade all the SS tables during that repair. As well, it is going to go to other nodes and say, hey, you know what? I'm repairing my local data set. Just make sure I have the correct data set. Okay. So you can see it is progress is 25% right now. So it is going to each node, get that information, and you can actually see that chat going on if you watch the log. So let me open another session and say tail -f system logs, system log. Okay. So you can see the background process, what it is doing. It is going and asking, hey, can you give me consistent view of users? Give me consistent view of application tables. And then it keeps doing that repair until repair is complete. Okay. So here you can see progress is 30%. Okay. So I don't have any special mechanism to make this run faster, but you can leave it running overnight and each node, one node at a time, just run the repair across the cluster, and all the repair is done. Your upgrade is complete. See, my repair command completed here on the node 3. So then I'll go to node 2, run the same command again. Okay.
Oh, I need to do it. Obviously, I need to do on all nodes. Okay.
Right.
So if I have like 100 cluster, I need to do 100 times.
Correct. But there are easier ways to do this. Okay. You have your SSH configured, right? So what you do, you script that SSH. Okay. What you do, eternal one. Okay. What is that you want to run on eternal one? First you source your, see, I'm actually writing your task plan on the fly. Okay. You cannot do this with Oracle. I just challenge you if you can do this. Okay. So that's why I'm so confident. So you see this, I said SSH eternal one, source the bash profile, which gives me all path settings, everything, and then run a node tool repair. Okay. Copy paste this. I'm going to show you one more interesting thing here. Copy paste this part. Okay, you have 100 servers. Okay, I'm writing a script for 100 servers. Actually, let me open another script file here. Okay, you have 100 servers nicely named. Okay, 24 servers. Each server name, you can use this. Watch this, don't blink. 1, 1, leading zeros. Okay, your server names are listed. Save this in a shell script.
No, how you did it?
That's why I said don't blink. Okay, this is
no. Why? Because I used Notepad++ so many times, but I always do this manually.
Okay, don't blink again. Alt C is a column.
Alt C. What is
Alt C.
What is the Alt C? Okay.
Yeah, it's called column selection or column fill. You can fill it with whatever you want. Like say, for example, my name. Okay, and it will fill that with my name. Or you can do a Control Z. Okay, or you can say instead generate numbers. Start with 1 or start with 200 and generate increase by 4 or 5 and then put the leading zeros and say okay, it fills. Okay, paste this in first server. If you have passwordless SSH configured from the first node, put this whole job, the SSH itself. Okay, my upgrade repair .sh and put this in background or no hop, whatever you want to do, whatever is your favorite.
So it will do one after the other, or it will
Correct. So it will go run this command and wait until that command is done.
Then only it will go here. Okay.
Correct. Or you can put a sleep. Now let me show you how I'll fill the sleep. So for example, after that command, sleep for 10 seconds. And then every command, it will have a sleep. Or you can stagger, basically don't sleep 10 seconds, but sleep for 3 minutes, 4 minutes, 10 minutes. And then accordingly you can stagger your cluster.
Yeah, but anyway, it will go sequentially, right? One after the other.
Correct. You don't want to,
no issues.
Your repair should run only one at a time in the whole cluster. You can run one repair.
What happens exactly that time?
Hold on. You can run one repair in one data center if you want.
Oh, okay. Got it.
Yeah. What was that you're saying? What will happen?
Yeah. Will it shut down, or what happens when
no, it doesn't shut down. But during repair, that particular node goes like, it doesn't respond to clients.
Oh, okay. Restricted mode.
it becomes restricted, but it is not really restricted because it still responds to the cluster and everything.
Okay.
Okay, there is just a special scenario. It just, you know what it does? Actually, I'll tell you what it does. As soon as you start the node tool repair, it goes and gossips, say, hey, you know what? I'm starting repair. And then other nodes will not send any request to this node. They will only respond to repair related requests. And then when repair is done, that node will say gossip, hey, I'm done repairing. And then it takes full responsibility of everything.
Okay.
All good?
Yeah. Anything else we need to understand to know more about gossip? Gossip is just a protocol type where it sends message. That's it, right?
Internode communication. So basically, node to node communication is happening via gossip. We don't really look at gossip. We just look at the system log, and you can see clearly each node is saying, I'm doing this, I'm doing that.
Okay.
Think of gossip as gossip between people.
Okay, understood.
Okay. So I have completed repair on 2 of my nodes. I'm just initiating on my third one, and then repair starts. You see the second one is also done. First one is also done. And third one is done. I'm starting on the first one. You see 22% because it might have already completed some repair earlier. So now it is just cleaning up the remaining. Okay.
Okay.
So that's it.